Okay. It's wonderful to have technology. Where we've come from so far to try to respond to this reality is we've begun working with our friends here at PJM, our other partners, Dominion Energy, many represented here, and others, over the years to begin looking at the most critical elements in a system engineering, multi-sector perspective on what has to be done. What are the most critical gaps? A couple of them will be discussed today. This morning we'll have a few sessions looking at resilient communications and an opportunity maybe to begin making some headway with one of the possible options in a resilient communication dimension, the energy sector web. We'll also talk a bit about a bridging layer that could be used on top of that web to help expand it and make it mobile securely, and that's the BNet system. But basically, resilient communications. We'll then move on and talk about the next problem. If you communicate, that's great. You have to communicate no matter what, right? In a black sky event, weeks into a power outage, you still have to have the key infrastructures communicating, but it's going to be massive chaos. Every operator is going to have tens of thousands of options, most of which he won't even know. And how does one sort through all those options? You're going to need computer assistance. It's too complicated for any one person to figure out. So we began years ago building a multi-corporate operating system framework called Genome, which looks like it can become a core effort, a core platform to help solve that problem. We'll talk about that. But that's just the beginning. What needs to happen is there needs to be a global effort of the best and the brightest universities, corporations, research institutions working together in a systems engineering framed process, not simply to do the FMEA analysis, which over time will have to evolve. That's critical, but also to provide the situational awareness and decision support, which can continue to operate in the middle of an extreme disaster. So there will be control centers where decision makers will have machine assistance in knowing what's going on in all sectors, what are the recommended solutions, how much time do they have to implement a solution before bad thing A or B or C happens. None of that is beyond current technology. What needs to happen is we collectively need to work on it. So we've actually made a good start. First of all, Tom and Mike, thank you. PJM is a member of this process. We're now in a membership phase. Jim Robb was unable to come because of his family issue, but NERC is also a member. Manny, are you here? Manny, the EISAC is a member, the National Council of ISACs is a member, the Water ISAC is a member, Northeastern University, thank you, Steve, Imperial College London, Cambridge, RAND has now joined the effort. Quanta Technology, thank you, Kevin. What I have said to people is, look, it is what we talked about yesterday, and just rolling the ball forward is not acceptable. It's not acceptable to me. I mean, we're all looking at a reality which the projection is end of game. If it's not acceptable, we need to work on it. If there is a better way than the Human Continuity Project to work on it, if somebody can find it, tell us, and we will divert all our energy into that. So far, we haven't found one. This looks like it's the game in town, and that seems to be why there are corporations joining the effort. So here's the question. there is room in this big tent for everyone. My question for you is, will you help? I recommend that everyone here think about it. If it works for you, bring your company into this process. Incidentally, it will not cost you anything because collectively, this global consortium, when we're ready, will put together a proposal and we'll seek funding. We have connections to some of the very big foundations out there. It will mean that some portion of your technical teams will be working on a completely unique project which will never end. Once this starts, it will just evolve with the infrastructures. It will grow and it will become something that will get built in. And it will depart before it goes too far from anything having to do with EIS Council, I'm sure. It will have its own governance board. So we're a catalyst. We're kicking it off. But that's the story. The first step in this process, if you haven't signed up for one of the 4 working groups that we talked about yesterday, please do so. That will help to keep the conversation rolling. But please reach out to one of us at EIS Council. We'll get you the information on the Human Continuity Project. Unless there's a better way, this represents what I think may be the opportunity for the leading corporations and the leaders, meaning you, to come together, collaborate, and solve this problem. So that's what I wanted to say to frame what we'll talk about today. It's an ongoing effort. I'm excited about it. I think just seeing the excitement that all of you showed yesterday, that's what excites me. You all represent the leaders who can take this kind of thing forward. So there's a short animated video that was put together for the Human Continuity Project. If it's loaded and it's working, maybe we'll play that, and then we'll move on. So thank you, everyone.
Into an organically integrated collective entity. But in the process, are we also cultivating a threat to human survival? Every day, the products and services of the modern world are combining and advancing. Developing into an increasingly complex and interconnected economic global network.
Can we add a little volume on this?
But interconnectivity means interdependency. If any significant function is damaged, the entire system could collapse. So, like a parent of a newborn child, until this collective human entity fully develops its natural resilience and recovery systems, we must protect it.
Okay. So that video can be made available to whoever would like to see it with the volume to hear it. But thanks very much. Chris?
Excellent. Thank you, Avi. I'll invite our first panel down of the morning. This is regarding the energy sector web. So that's Scott Blevins, Udi Ganani, Tim Schwartz, and I believe Carl Eng from Dominion will be joining us on virtually.
They're going to do it. Just say next slide.
Yeah. And these should all be working, so I'll hang on to this. Oh, and Tom, sorry.
Oh, sure.
All right. Good morning. Like Chris said, we're looking at two major things today for Black Sky Communications, emergency communications. One, we've been working for several years on the BSX BNet capability, and we deployed some of that down at Dominion, working with Carl. And so we're going to talk a little bit about that, and then what I'm going to call a new to you initiative that we've been working on. It's not new to us because we've been working on it for several years now to get it going through COVID and everything, but it's called the Energy Sector Web, and it's a way that we're looking at breaking the positive feedback loop, kind of going to what Avi was talking about, finding those points of failure. We've been relying on, one of the things that the energy sector has to rely on is external telecommunications in the event of a black sky. And so what they've always talked about is how do we control our own fate? How can we take that piece of the equation out? And so the energy sector web looks to do that and put that ownership and control in the power sector where they need it. Next slide, please. Here. Next slide, please. Next. So we were going to start, Udi was going to give us a quick overview of what we had done previously with the BSX and the BNet. And part of this you will see, and we did it during GridX, we did a link from the BSX BNet back to from Dominion back to PJM, but we relied on a satellite link, and we saw that as being like the weak link in this, which was the genesis of why we went from there to develop the energy sector web. How do we get that piece of the equation out and put it down here with the energy sector where they own it?
Okay. Thank you, Scott. Avi started with revealing his background in the aerospace industry. That's honestly, I met Avi when we both were with the aerospace industry. I spent my first 30 years with Rafael, which is, I think, by now a well-known aerospace and defense contractor in Israel. And BNet was developed as the radio system that when Israel received the first batch of F-16s, we had our set of requirements, and BNet was developed as the radio that was used by the Israeli Air Force, migrated to the land forces, and today is been thoroughly tested by both the UK, Germany, and as a matter of fact, the fourth largest military in the world, the Indian Army and Air Force, equipped themselves with BNet radios. BNet is a MANET, a mobile ad hoc network. That means that you don't have to rely upon any stationary data center or fixed towers, and it's a self-forming, self-healing radio with the unique capability of each radio serves as a virtual internet URL. That means that you don't really need to have a direct line of sight between the radios to operate. You actually form that network, and if you are down at Richmond and you have a network of those radios, you can communicate as far as you have a radio. We demonstrated that capability at PJM and at Dominion Energy. I think it was the GridX right before COVID, and hopefully that's the video that I'll be sharing with you within a moment. I mean, there's plenty of videos here, so I'm not sure, but in any way, it's going to be a video. So please, Lihi, push the button. And is Carl Egg there, or just his name is posted?
Carl, are you there with us?
I'm here.
Okay, good.
Roger. Good morning, Carl.
Good morning, everybody.
Do they wait for the secret code? Next slide. Next slide.
Next slide.
No. Okay. Okay. All right.
PSEG Long Island says it's rooting out the causes of its communication glitches that did not happen in previous storms.
Cyber intruders inserted ransomware inside systems of energy giant Colonial Pipeline, making demands for payment.
Being a military piece of equipment, the installation is extremely straightforward. The challenge is hooking the radio into your IT operational system. We did it at Dominion. There's no reason why it can't be done elsewhere. That video was made 3 years ago. What we did in Israel 3 years ago, we put all critical infrastructure together in a network that had less than 10 radios. We communicated live between those critical infrastructure.
שלום, אנחנו נמצאים ממש על גבול הדרום
Okay, thank you, Lee. This was supposed to be the last video, but anyway, I'll try to juggle. The main feature that makes that radio so attractive, and it was explained thoroughly by Scott yesterday afternoon, is the fact that typically a radio has a designated slice of spectrum, and that creates a limited bandwidth. That military radio serves as looking at the spectrum and jumping into available pieces of spectrum. I mean, this is meant for black sky situation where nothing supposed to be operational and there's a lot of spectrum to be used. So that creates a huge bandwidth that allows throughput. And the fact that we don't rely upon any data center or towers allows that network to grow. I mean, we can have 1,000 radios on the same network, and the more that you have radios in the site, the better the communication capacity is. Next slide, please. Now, usually we're very spoiled in terms of using mobile devices and other means of communication. And we've got cellular, we've got data center, we've got fiber. But in case of a black sky event, everything drops down. And in extreme catastrophe, we've got very limited communication capability. But next button. Now, we don't need to cover all of that gap in order to recover from a black sky situation. Please push the button. All that we need is bridging that gap by using a BNet radio. And just to summarize what BNet will give us, it's a very robust network. And again, 30 years ago, or 30 more years ago, the Israeli Air Force already got an EMP requirement. So that radio is EMP protected. I mean, I don't think that there are many commercial available radios that are currently being used that meet that requirement. It is, since being a military equipment, it's meant to operate on the move. So if you recall the last video that I had, we demonstrated an operational team of the Israeli Electric Company that was traveling along the Lebanese border, and we're transmitting using BNet a live video of the incident. Again, I'm not sure that the world simple IP integration to existing system is true, and that's why we have Carl Eng on the line to say how simple it is. It's definitely cyber protected, and identifying the spectrum is the feature that allows us to transmit through that radio as many as 3 or 4 HD quality videos, data, and obviously voice. Next one, please. Next slide, please. All right. Okay. No, I don't want to show that again. Try please the one that shows the 2019 GridX demo. Well, sorry for that. Scott, over. No. We've done that already. No.
Go ahead and stop that video. We want to do the 2019 demo.
Right.
And that'll show you the connection that we had coming from Dominion up through to PJM. And again, in there you'll hear the satellite part, and that's the part that we wanted to replace with the energy sector web, is getting the satellite out of the link. And then obviously the other advantages it gives us besides just that link.
Can you stop for a minute? Scott, can you explain the background for that
So
demo?
in that scenario, I had worked with Carl Eng at Dominion to deploy some BNet units down there at Dominion. During that same time, during GridX, they had the Energy Sector Coordinated Council was working with the Emergency Communications Working Group, and they were testing out various technologies, and satellite being one of them. They were looking at LEO satellite, GEO satellite, et cetera. So during that exercise, he said, well, what if, could we connect from Dominion back to PJM across satellite and extend that out there? And I'm going to call it the tactical edge. Can we extend that all the way out there to a substation down there? So I believe we were at Chesterfield substation with the handheld, and we talked back through Dominion's control center, and then up and over satellite back to PJM, and we were able to have that conversation. But in that, when we had done the deployment down there with Carl in Dominion, one of the ways that we connected the BNets back up was over fiber optic. And during that time frame, and I'll touch on this when I get into the energy sector web part, one of the things that we found in that was that they had a lot of fiber because of this technology called optical and ground wire, which is fiber optic that's inside the grounding wires that's on transmission towers. And so we found that utilities have a lot of this, and a lot of it was being unused. It's called dark fiber, so they don't use all the strands, they only use a few strands. And so that's when Carl and I were talking, and we said, what if? Could we get a fiber connection from Dominion to PJM? We had to go through Exelon. Could we get that connection going and take that satellite out of that link? Because, again, satellites are vulnerable. We've talked about that in many of these conferences about the vulnerability of satellites. And it's something the utilities own and control. They own and control the fiber network. They own and control these things, and they can EMP harden it, and there's some other technologies that they can leverage that can make it much more robust, and it takes it out of the hands of the telecommunications sector and puts it all into the hands of the energy sector.
Please continue.
We started working on that, and these guys are the guys that did it: PJM, Exelon, and Dominion that we have up here. And it's not just supporting the VNet or that's out of the tactical edge, but by linking those control centers like that and whatever technologies you want to link into it, now we can support any of those technologies, just like you would normally have on the web. That's why we call it the energy sector web. Voice, video, data, SCADA, all those kind of things can be supported because we've got this fiber optic backbone in place. And so that's what it is that we set up, and that's what we've been testing. So,
Scott, let me add to that. Basically, when we started down this path, we looked at the BNet radios, and they required a broadband spectrum, which we didn't have. And we looked at our fiber as basically a backhaul capability for the radios between the key facilities where we could leverage the radio after a black sky event. So we built a network using our dark fiber, and the reason we wanted to use dark fiber is that way we can ensure the entire network is hardened for an EMP event. So once that was in place with all the BNet radios, we had this infrastructure in place, and it was a simple matter to work with neighboring utilities to interconnect that technology. And that's formed the foundation of the network to Exelon and PJM.
Can you show the next one, please? Okay, one of the features of the BNet radio is it can serve as an LTE, a local radio with interconnectivity to existing legacy pieces of communication. And here we just demonstrate how one radio can collect data, continuously collect data from sensors and transmit the data over the network. It can not just from sensors, but from legacy hardware. I mean, we show that we can communicate with a Motorola handheld devices. And please show the last one. Next slide. That's the layout of the all utilities demo that we conducted in February 2021. If you recall, this was 1 year after the COVID started. From Hadera up to the Lebanese border, which is about 60 miles, and the width of that piece is about 30 to 40 miles. And as you can see here, we had first responders, firefighters, and police. We obviously had the electric sector represented here, substation generation. We had a mobile operational team, and we also tied it into the Haifa port, which is the main entry in terms of transportation into the country. So, I mean, we're here. Avi spoke about the human continuity project. This is a human continuity project on a regional or on a state level, or even on a county level, where you have the emergency manager who oversees all those elements and more. Next one, please. Okay. There is one video that I wanted to show first. Maybe since we've already played all the videos, this is going to be the right one, and that's the video that Scott spoke to about the GridX demo that Carl and Scott did 4 years ago. So maybe you guys up there will find it finally. Yeah, I think they only work when we say next slide. Next slide. Lihi, are you there? All the videos. Okay. Well, anyway, thank you. Over to you, Scott.
Okay, go ahead. Next slide, please. Okay, energy sector web. So, go ahead, next slide. Next slide, please. So, energy sector web. So I want to move through this pretty quick so we get the panel some time to talk about some of this stuff. But we've kind of touched upon this. What is the energy sector web? Well, it's this leveraging of this dark fiber assets that the utilities have in order to create something that they own, something that they control in an emergency. And we're actually going to have like a second session after this. So this main one's kind of going to be about what we've talked about or what we've done up to this point. And then the one following this one's going to be focused more on how do we grow this? How do we go from here? How do we move forward from there? Again, I've talked about this quite a bit. Why do we need it? And as Avi was talking about earlier, you know, your single points of failure. One of the big issues that we have in catastrophic outages is the grid operators rely on traditional telecommunications, but traditional telecommunications relies on the grid. So if the grid goes down for an extended period of time and we lose a lot of our traditional telecommunications, then it's hard to get the grid up without having a lot of communications capabilities. And a lot of times, we touched on some yesterday, prioritization of restoration. Who gets prioritization first? Is it the hospital? Is it that generator? Sometimes the electric sector isn't always the top of the priority in the restoration as we're making all these decisions. So the more that we can move it to being 100% owned and operated by the energy sector, the better position that we're going to be in. So that's what we really focused at on the energy sector web, was putting something down to where the utilities actually owned it. This is kind of our concept diagram of what we were looking at doing. We don't have all these pieces in place today, but that core center part that you see connecting Dominion through Exelon to PJM, those three groups being tied together over that dark fiber. And Exelon really brought something to the table for us. They brought along their what's called dense wave division multiplexing, which what that allows you to do is use different wavelengths of light down the same fiber optic path. But from a cybersecurity point, it creates a physically separate network. And that's important because what we had to do here was we had to create a network that wasn't on anybody's network, right? Because I can't tie three corporate networks together. That would be very difficult. And a lot of the challenges that we faced was the legal and the cyber security aspects of how do we do this? How do we create this network that lives out there in between these guys? And so that was a lot of the difficulties that we had to go through. But with that capability in there and it being fiber, then we could connect all those different things, right? We can connect radios to it. We can connect phone systems to it. We can pass data. We can pass phaser data. We can pass SCADA data, et cetera. So that was our initial design concept. We talked about being as part of that. I talked a little bit about this optical and ground wire, but that's what gives us that capability, this dark fiber is why we have a lot of it. I put the bacon on there as a nod to Terry Boston. You know, he always says bacon makes everything better. But in my world, fiber makes everything better, right? If you give me fiber, I can give you any kind of capabilities from there. And we talked about what DWDM is. So you go back one. Okay, so from there, that's just kind of a quick overview of what the energy sector web is. Again, these three companies here were kind of the pioneers of putting this thing together: Dominion, Exelon, and PJM. Again, always talks about people are admiring the problem instead of doing something about it. But we decided to do something about it at this conference, the last one we had before COVID. That's where we made the decision. Let's try this. We've been talking about it. We kicked around the idea, but we went into a little side breakout room and said, can we get agreement? Can we actually do this? Can we actually move forward? And so even though we had COVID and all those things in between, we did it. We've moved forward. We moved that peg forward. So I guess now I'm going to go to the panels here. Let me talk to, so I'll start with Carl, but can you talk about what kind of drove your organization to pursue what we call this initial pilot test that we're now calling Energy Sector Web?
Sure, Scott. Dominion recognized, based on our geographical location, that there are additional threats from hemp, EMP attacks, et cetera. Where Richmond is about 100 miles south of Washington, D.C., so that's certainly a prime target. And if you're aware of how EMP energy propagates, it goes to the south because of the polar magnetic fields. So basically, Richmond is kind of ground zero. So based on that, we began a program this about 10, 12 years ago to look at hardening key assets to protect against that threat. So we've hardened a control center, and the next logical step was to look at hardening some key communication systems for key facilities. So the way we looked at it is, what do we need if there was an EMP event? Basically, the key there is to restart the grid with whatever resources, whatever generation resources you have. And the key to that is communications, being able to communicate with a power station that's 50, 100 miles away, 200 miles away, is vital. So we identified some key facilities, established a pilot project to look at BNet as a communications venue for that system, as a foundation for that system. We got into it, realized that we didn't have the wideband spectrum that would be needed. So that's when we looked at alternatives and realized, hey, it's an IP-based radio system. We've got plenty of dark fiber, or plenty of fiber, and we made a conscious effort to use dark fiber so we can design the electronics to be hardened that support that fiber. And that formed the basis of the foundation for communications between the control center and these key facilities. So, and once we got out there, the BNet radio acts as a base station, and we could use handheld walkie-talkies to talk with folks that are around that site. So that basically it's just a piece of the puzzle in an overall plan to harden our assets, our key assets for these threats.
Thank you, Carl. Over to you, Tom. What do you think kind of drove PJM to kind of explore this, initially what we called Pilot 2 that we're now, moving towards the energy sector web?
Yeah, thanks. And, I would say a couple of things. First and foremost is, we kind of began this journey around resilient comms, probably 10 years ago in terms of recognizing that the industry needed something. So there was a lot of discussions that we had, and I think, as you had recalled, we, at the time, PJM was one of the co-leads on the Resilient Communications Working Group, which was part of the Electric Subsector Coordinating Council. So we definitely saw the business need for this in the long run. And I think we looked around and we've seen like multiple pilots across the country, different types of communications. The one thing that was very interesting to us was this notion of utilizing dark fiber. And as you had indicated, a lot of utilities, particularly back in the 90s when they were trying to figure out what their business was, they started stringing a lot of fiber that's unused and untapped. And we had conversations around, could we build our own version of the internet within PJM, but recognizing there's a lot to be done there. And we thought that, supporting this pilot would be something that we could learn from and perhaps at some point build out to scale. And this may be part of the later conversation in the day. But the other thing that, and Avi and I talked about this last night a little bit is, once you do these pilots and you start to figure out where might you go with it is how do you build a governance mechanism that allows you to actually operate a system like this, because it doesn't quite exist yet.
Right.
But we can talk about that later.
Yeah, and that's exactly as you see it on the next slide that we'll be talking about. And I know we kind of threw you in this because you weren't, Exelon's been really a key partner in making this happen. And I know we kind of threw you into it at the last minute, but do you want to talk a little bit about maybe, what Exelon, why they kind of pursued this and everything?
Yeah, thank you. So Exelon sees this kind of as part of our journey of resiliency ourselves, and communication, we were talking about black start restoration and some things like that. If we can't talk to our neighbors, if we can't talk to our generators, if we don't have the data, coming in from those folks, we have nothing, and you're not going to get power anytime soon. So being able to talk to, PJM, our neighbor at Dominion, we have multiple ties with Dominion, being able to talk to the generators in our zones for black start restoration is critical. Certainly this is a piece of the puzzle for Exelon. We're in the middle of a control center project right now with EMP proofing our data center and control room fallback. That's all 6-sided shields. Our backup generators are all within a shield. So all of that is massive. And again, this is just kind of part of the puzzle of making sure that, were there, something like this to happen, that, we're ready, we're there, and, we have systems, our SCADA system, well within the shield, being able to leverage this, perhaps even with our communications with PJM, not just voice, data. Right now, all of that is through, Verizon, AT&T. Can we get to the point where that's kind of out of there so we can exchange data with PJM? Obviously, Exelon's 50 gigawatts of PJM's load, so, a large chunk of it kind of right here in the middle of the Mid-Atlantic area. So,
Tim, quick question to follow up on your points. You focused a lot when we had a previous discussion on if you can't communicate, you definitely can't black start, and operating is even hard. In a black sky environment, I wanted to ask, so it is possible to do this sort of by hand using voice, but that takes a lot of hands and a lot of daisy chaining and that kind of thing. Can you talk about the leverage that it would empower operators when you're able to then have data, have additional information that it's not just voice, it's not just by hand, and having that coordination data over a secure communication network?
Yeah, right. So during black start restoration, there's a lot of things going on. We're trying to, one, get power to folks, right? And two, we're making sure that the island we're building up is stable and it's able to at some point get big enough that now we're starting to have further applications run to make sure that the system can withstand the next loss, and there's enough inertia and things within the island that it can get up and run. And if we don't have that data so that we know what all those generators are doing and where our under frequency is and how much load there is and making sure that all that's accounted for, it's almost impossible, right? So, I appreciate the question, but that's the stuff that we need to have that coming into our SCADA system. We need to have that information there in front of the operators so that we know that as we're going through, we can make sure that, I think it was Mike that brought up, once we start and get an island going, we don't want to start again and again and again. That's not ideal, right? We want to get that island going and build it and keep it growing and growing and growing until we get back to the point where we're reestablishing the Eastern Interconnection again.
Avi had a question.
So I think one of the really valuable things about what you collectively have achieved with the energy sector web, Dominion, PJM, Exelon, is the lessons learned so far. And in that regard, can you speak to what was easy, what was hard? I mean, what are the key things that we can take forward? What has been learned?
I mean, anybody want to take that? Because I was going to say that's exactly what one of my questions was what were some of the challenges? And I know from my side, just kind of being, we were kind of like a catalyst in this and kind of hosting it. But I know legal challenges, getting it past the lawyers to agree that they could be done, and the cybersecurity challenges of getting the cyber guys to nod and say it's okay. To me, that seemed to be some of the bigger issues. The technology, and I don't want to take anything away from the technology guys, but that was the easy part, it seemed like to me. It was these other hurdles that we had to overcome, and that I think needs to be the model on how we move forward, if they can look at that. Did you want to take that one, Tom, to start with?
I mean, I'll just add to what you had said. Is I definitely think the kind of legal and the cybersecurity issues were, kind of top of mind. From a PJM perspective, I think the thing for us was it was kind of the people side of it. Is that, we have a lot going on. We're maintaining a lot of systems, and we've got limited resources. And we wanted to make sure that we supported it. And in the long run, if you want to go forward with it to scale, it's going to take a lot of horsepower. And I think our challenge is, I think we'd be willing to go further if there's light that you can see that this network is going to happen. But, you know, I don't think we would be in a situation where we would stay in pilot mode for too long just because we're pulling people from doing, you know, other tasks, you know, in the areas. But I'm interested in seeing, you know, where does this go? Where does other interests lie? Because at the end of the day, I think the concept is good. I think what Dominion has done is really, really good with the Rafael system. And I think there's something to build off of, but it has to be something that can be built to scale. And if we're going to do that, then it's got to be prioritized. And we talked about that a little bit in the working group yesterday. And, you know, that whole prioritization, you know, mechanism is what will drive us to, you know, keep moving, is that if we see light at the end of the tunnel and we see the value that we can get out of it in a, you know, in a reasonable amount of time. But that was, to me, the people side was the biggest challenge. That was pulling people off of their day work to support it.
No, we appreciate that. What about you, Carl? Did you want to go ahead and talk about that a little bit?
Yes, Scott, I was going to say the technical side was fairly straightforward. I think where we may benefit is if we look at that technology and look at it, adopting it to support, you know, standard infrastructures, like having an interface to a private LTE system. Things like that would really enhance the value of that capability, of that technology. But I would agree that the legal and governance issues was probably the biggest challenge, which frankly, you know, I'm an engineer. I really didn't see that as a big challenge, but as it turned out, it was to me, one of the more difficult challenges to overcome. And also the FCC licensing for those radios. So, but that hurdle's been passed. So, you know, we covered that ground for it.
I'll get to you in just one second. Let me just let Exelon go ahead and speak to that real quick, and then I'll take this question back here.
Yeah, I think legal and regulatory is always one of the biggest ones, right? I'm an engineer too, you know, so I think, oh, there's nothing we can't do. Well, it turns out, yeah, sometimes we can't. But you know, getting through the red tape is certainly a big challenge to get through.
I had a question back here on the blue shirt.
Yeah, Craig Glazer from PJM, and I'll move this away from blame the lawyers to something a little different. And really a question for Udi. How did these technologies help or frankly not help on October 7th in Israel? I'm wondering if you can comment on that. Was there a role for them at all? And looking back, is there something that could have helped? Obviously not obviated, but just help mitigate some of the impacts.
You're placing me in a rather embarrassing position because unfortunately on October 7th, the military was nowhere around during the crucial first 8 hours. And surprisingly, what was operational during those horrible 8 hours was cell phones, that victims of these atrocities actually contacted TV reporters and relatives across the country. For some reason, the towers were not knocked down, so that enabled cellular communication to function. Didn't help us much. But on all other fronts, I mean, BNet is one of the best available military radios with all the features that I listed.
Let me move forward with this because we've only got 5 minutes left on this one, and then we're going to have a break, and then we're going to come back and talk about where do we go from here. But those three issues right there, those are a lot of what we're going to have to explore in this next session of how do we take what we've learned here and how do we move forward, like who can connect, legal and regulatory, and cybersecurity. This is just a kind of a quick view. Because of using that technologies, we've got 3 control centers connected up. We talked about Dominion, Exelon, PJM. But because of using technologies like DWDM, et cetera, I mean, this is the kind of an addressable area that we could actually support right now with the energy sector web. And parts of this are actually EMP hardened. There's some parts of it that Dominion has worked out that are actually EMP hardened. And then when they leverage that with things like the BNet that I talked about it being on the tactical edge, I mean, you could obviously push that out wirelessly and extend that link further. But part of that's going to rely on, and you all hear me talk about this a lot, spectrum and everything of how do we get data spectrum. And that's still something that we're working to solve with some of the regulatory agencies. And then this is a lot of what we're going to be looking at, and I really need your all's help in the next session, is how do we grow this energy sector web? You know, if let's say we get the PJM footprint and we get it all operating and working within PJM, you know, part of when we do a black sky restoration, and obviously I'm not the expert, the experts are here, but, you know, how do we talk between these reliability coordinators, you know, that's going to be an important part. And so, you know, I was asked to throw out, how do we phase this out, right? So I kind of looked at PJM, building that out, and then TVA has expressed a lot of interest in this. In fact, they'll be joining our next panel. So I just kind of looked at the map and built it out this way, but that might not make sense to the energy sector guys to build it out this way. They may have a lot better ideas on how we would move forward with that. Any last comments before we take our break? I'll start with Exelon here first. And no. What about you, Carl? Do you have any other last comments you want to make on this session right now?
Not anymore. I think we started something that certainly provides a model to look at going forward. So, hopefully we can expand from there.
And then I got one question back here, and then I'm going to ask Tom to give his last.
Yeah, thank you very much. Kyle Hanna from Dominion Energy. Carl on the phone, Carling, mentioned interoperability between BNet and something like a private LTE network. At Dominion, we've been looking at investing in a private LTE network. The BNet that you talked about is a great option between our communication centers and critical facilities and critical substations. And we feel good about that. But we're also looking at having a robust utility-grade communication to our field personnel, so the support staff that are going to be required to respond to an event. And we've been looking really hard at private LTE. Could you talk a little bit about how one might think about private LTE and interoperability with VNet?
Well, private LTE, and I know a lot of things are moving in that direction because, we're so used to using our cell phones, right? So private LTE is just really just a corporate version of the cell phone network, kind of like how things moved away from buying your phone service directly from AT&T, and a lot of businesses moved into setting up their own PBXs, private branch exchanges. So that's kind of a lot of what you're looking at with private LTE. And a lot of people are so used to using the cell phone, it makes sense, right? The issues with a lot of the private LTE stuff, though, is when you look at it from an EMP type perspective, there's not really a lot of options out there that are EMP protected, EMP hardened. There are some ways of doing that. Rafael actually has an EMP hardened LTE system that's out there. There are some other manufacturers that have it. As far as the direct interoperability between the BNet and a private LTE, what we worked at with Dominion and with Carl is we go through, I believe it's called the AvTech system, that ties in their PBX and their radio systems. And so we can actually bridge those calls between the private LTE and the radio side of it. So there is one way of looking at it for interoperability there. Now, I'd like to go ahead so we can, I think we're on our break time here. Any last comments on this?
I'll just be really quick. I think, kind of going back to some of the conversation that we had the last day or so, is it's prioritized. It's voice first, data second, and then when we start looking at data, what is critical data, and not trying to go and solve the whole data problem overnight, because it's going to take time. And then finally, it would be that if we get something in place, how do you sustain it, and how do you make it part of your normal communication so that it's always there? So.
Thank you, and I think I'll turn over to Chris now to.
Okay, thanks. Thanks to the panel. Thank you. Great presentations. We'll take a quick break. Come back for part 2 of Energy Sector Web at 10 a.m. Thank you.
Just a word, Aviv from Rafael is here with us, and he will welcome any further questions that you might have about the BNet radio. Thank you.
Leave that there, and I think it'll end. You know what I'm saying? But I want to be able to go back to the presentation. Yeah. Yeah. I don't know if I can make it. Oh. I'm sort of see what you're doing. Yeah, 6 hours, I think. How old? I see your daughter, but he works for Lumen. Okay. I think would be. Okay. Oh, okay. Yeah. Okay. I'll share that with Scott and the main team. Thank you. No, that's really helpful. I mean, that's what we're looking for, is like partners to help move this forward. You know. Okay, so you emailed me? Yeah. Okay. Okay. Yeah, he's a really good guy. We've been working together a little bit on some stuff for Theo. I appreciate that. I will announce, like, I'll send Scott. I can ask her. So she has it. Right now it's in a huge, it's in like a massive check for the whole conference, which I think we can share with you. But a lot of it's stuff like this. But yeah, we can definitely share that. Yeah. Well, and also it was that side by side too, so we barely, right? It was pretty hard. Like if it would have been a slide like this, it would have been okay, but since Ranger was on, then they had it half the size. Oh, really? Oh, okay. Okay. No. Right. Oh. Oh. That's so old school, right? Thank you, Dave. How many would you like? The whole thing should be out in a couple of weeks. So this is just the executive summary. So it's going to be a whole handbook. It's about 200 pages. Downloadable and hard copy. Kindle? Sure. Yeah. Yeah, we put them on Amazon, so. Yeah. The last one, we didn't do it with the older ones. We have, this will be our fifth handbook. The first three we just printed, and we have PDFs of them on our website, and then the fourth one we put on Amazon. So you can get a Kindle version, or you can now, get a hard
Well, I grabbed the one that you signed up yesterday, so we grabbed the second part of the Energy Sector Web panel to come down, and we'll also be joined virtually by Ian Grant from Tennessee Valley Authority.
Yeah, we said that.
Tom is going to be here?
Yeah, I'll just start going. I'll make his way down.
All right, if y'all want to go ahead and take your seats, we're getting ready to start on the Energy Sector Web Part 2. And this is going to be much more focused on how do we move forward from here.
Folks, can I ask you to take your seats or take your conversations out back?
Good job. אל תצעקי עליהם.
Thank you. I'm joined up here with Udi and Tom, and we should have Ian Grant on the line. Ian, can you hear us okay?
Hey, Chris, he's trying. He just called me and said that he's had to reboot his computer and then he'll try again. So.
Okay. Well, we'll wait for him to join in there while we'll talk about. I'll kind of set this up. So, you know, we did the basics of getting this thing put together in place, getting the fiber in place, getting the routers and those kind of things in place. Again, we talked about how fiber can give us lots of capabilities and we can push a lot of things beyond that. And that's the technical side. This one, and I really want to get a lot more audience engagement on that stuff, and especially from the leadership within the energy sector, is like, how would we move this thing forward, right? I mean, we talked about, the wrong way, we talked about, you know, how do we get the legal and regulatory in place? Who can connect? Like, if we were to build this and say, so we got this going on, right? We've got the Dominion, we got PJM, and we got Exxon going on. Okay, now we want to add another company in there. What's that process? How would they connect? How can they do that without having to go through the same legal and regulatory hurdles that we've got? You know, one of the things that I posited was that we have this governing board, this Energy Sector Web Governing and Security Board that looks at how we do this, how we onboard people, how do we grow it from there. So that's kind of really the discussion I wanted to have here. And I'm going to just start with Tom. What's your thoughts on that, like how we could structure something like that?
Yeah, I would say a couple of things is, you know, when I think about like the long-term sustainability of a network like this, is it really needs to be managed, and it can't be managed like by, in my opinion, like a single company. Like PJM can't manage it across all of the Eastern Interconnection or across all of the U.S. And there's a model out there that we use, and I'm not suggesting this exactly, but something like this. There's a group called the Eastern Interconnection Data Sharing Network, which was established following, NERC used to run a network called NERCnet, and they wanted to get out of that business. And, 10 or 12 years ago, the EIDSN was formed, and it's really a virtual company. And it's a company that has, a couple of people that are managing it, but the members of that support the working groups. They support the technology, the tools that are built on top of it. And I don't think this thing necessarily has all those tools. But I think there is a governance structure, and there's a legal structure, and there are ways how you interconnect, and there's standards, and there's all of those things. And this virtual company built it. So I think something like that, where if you had, whether it be the balancing coordinators or whomever, that type of model, I think, would be necessary for it to be sustainable. So I'll stop there for now.
Great. That's kind of exactly along the lines that I was thinking. And, we talked to the EISDN about this. And at some point, we have this, the energy sector web piece of it. We have the EISDN. Is there at some point in the future some communications between, both those entities? And we had talked about, if we get this up and running, do we kind of move it to the EISDN to manage it? I mean, those are some of the ideas we've thrown out. Again, these are just ideas that we've been throwing out, and that's kind of really what this panel was more about, was let's explore some ideas, right, like of how to do that. Do we have Ian on yet? I didn't know if Ian had connected yet or not. No, not yet. Okay. So let me move this forward to here. The other piece of this too is how would we grow this, right? Like like I told you in the last discussion. Now this was just my idea, phase 1, 2, 3, 4, but I'm really just looking at a map and kind of throwing it out there. That may not be the smartest way to move it forward, but I would like some discussion on that too.
Yeah, and I think I would go back to, I still think there's a government involvement with this, and and I look at, whether it be DOE or whether it be NERC or whomever, but there's, I think they're part of this process, and they're part of the process even from a potential funding perspective. And we had talked a little bit earlier about the resilient communications that were part of the ESCC, and back in those days, we did pilot some things, we had some success, but there was a discussion around, well, how do you move it forward? And I think moving it forward, I think having some type of government support for the build-out, government support for the need, and I know, and I've said this probably 3 or 4 times today or in the last 2 days, but it's a need that has been identified by the GridX exercises that Manny and his team lead, and I think engaging that community with these companies is important. And if you look at like phase 1 and you say PJM, obviously there's been discussion with Dominion, Exelon, and PJM, and we built this thing out. The next question is who else in PJM is interested? What other transmission owners or whatever, and are they interested? But I think you got to start somewhere, and that's a possibility.
Great, and I think Chris gave me the signal that Ian's joined us now. Are you there, Ian? Oh, okay, I thought.
He just told me he was connected.
Okay. Well, we'll go ahead and take a question while we're waiting for.
Well, maybe a suggestion of it as well, embedded in the question. Have you, working with the National Governors Association, working with the Conference of U.S. Mayors, like National Governors Association has a Center for Best Practices, U.S. Conference of Mayors sponsors the initiatives, then you get the mayors and governors, obviously up to speed a bit. And to what extent have you guys been connecting, I guess, with that community? Because I think that helps you more than just trying to march up to DOE and the rest. At the end of the day, this infrastructure is located in states and territories.
I think Avi has an answer to that.
Well, there's no question they need to be involved, at some point. But remember, this is a private sector, electric sector initiative.
Right.
for ownership by private corporations. So, you know, what will need to happen if the industry wants to move this forward is that there will be a governance board that will be set up by the corporate entities. And that governance board would, for example, be deciding on membership as a function of time. But
I guess what I'm trying to get at, part here, I think the two often go together. You know, the corporate folks are more, if this is something that I think there is political support for, that this is, you know, the signal from the governor or mayor is, I'd like this to happen, and then that makes it sometimes easier for them to say this is worth investing in versus the other things that I have. I mean, it's finding, of course, that timing, but it is that you've got entities who are marching off thinking about best practices for dealing with this that maybe have no idea what you're doing.
you know, making sure that relevant government entities know this is happening, if it's going to happen, and as it comes together, is relevant. There, I think, is a compelling sense that it will be important to avoid this becoming a government-owned effort.
Yeah.
This needs to be, if it's going to do what it needs to do, it needs to be a energy sector effort. And over time, you know, whatever the governance board is may decide to expand it. But having awareness at the right time, I think you're right.
Yeah, Avi, just a quick comment to that is, you know, I think your perspective on it, you know, not being government-owned, not being government-managed, does make a lot of sense. I think to the question, though, is if there's funding that needs to be done, clearly, you know, utilities need to be working with their state, you know, public utility commissions and all of that from a rates perspective and all of that, and certainly PJM. Being governed by FERC, you know, and things like that. I do see government involvement, even though I don't see it as government-run or government-owned. But because I think there's support that they can be providing to this that could, you know, help move it along. So I think it's a fair question.
Yeah, you know, I want to be clear that when I'm talking about this, it's not about this being taken over by the government with the mayor and governor's level here. I mean, they really have that capacity to do that in any event, but their awareness and their ability to translate into this is something that is of value, I think makes the private effort to solve the problem potentially that much more viable. So.
Steve, I think I've been corrected by the panel, so it seems like earlier rather than later would indeed make sense. And I think if it looks like it's going forward, this would be something that whatever fledgling governance board begins coming together would work with in terms of engaging with the National Governors Association and so forth. So any follow-up ideas you have on that, I think will be great. I sit corrected.
Thank you. I don't know, was Ian able to join us yet? Okay.
Ian, is your mic muted?
Ian's on.
There we go.
Sorry about that.
Ian, I don't know if you've been able to listen so far to the discussion. If you had, was there any inputs that you wanted to be, you know, to discuss real quick or anything?
I'm sorry I spent the first few minutes wrestling with a recalcitrant computer to try and get in. But I would like to express TVA's support for this. TVA is presently working through a program in its own communications, and we are, I believe, working towards filling in or reaching what I see on your screen here as phase 2, participating in this. Very enthusiastic about that. We're just in the process right now. So don't have a quite definite schedule yet, but definitely moving towards it. Thank you.
Yeah, thank you, Ian. So I'll just kind of catch you up to speed on that real quick, and then and then maybe you can speak a little bit to that as well. So when we looked at growing the energy sector web, there's kind of two components there. One piece of it that we're kind of discussing on this board is what kind of governance board do we need? What to talk about, the cybersecurity stuff, the legal and regulatory stuff, the decisions on who and how people can connect to this thing, and then the second piece being how do we grow this? How do we grow the energy sector web? Looking at initially phase one, we talked about PJM because PJM has already started that with the two companies that they've got. TVA is doing their stuff as well internally. And then, when do we make that talk between PJM and TVA? We don't have to probably build all of PJM out to make that connection, right? But we have to have that, just like in order to get from Dominion to PJM, I have to work with Exelon. In order to get from TVA to PJM, it looks to me, looking at just a map, I know I've heard that we have to go through Duke. I see Duke and I see MISO, so to me it's like, well, you got to go through one of those two. But I'm not the energy expert guy, so maybe you all have a better path of what that would look like. Did you want to speak a little bit about the governance board piece of it, what your thoughts are on that? And then I think Tom had some comments he wanted to make.
I don't really have anything useful to contribute about the governance board part of it. TVA is federal, as you know, so we're more self-contained than some of the organizations that have PUCs to answer to or external controllers to answer to. So we have some degree of freedom there that perhaps others don't have. On the other hand, being federal, we perhaps have less freedom in some ways too. So in any case, I guess the bottom line of what I'm saying is no, I don't really have anything useful to contribute about the governance other than to reflect that all the organizations you mentioned we are on good terms with. We've got good communications between us in different aspects. So I don't see any holdup. I don't see any barriers to be overcome to work between these organizations.
Thank you.
Yeah, and I'll just jump in. When I look at the phasing, I think there's a couple questions that come to mind. And the first is almost irregardless of the phasing is what is the state of the dark fiber that's already out there in terms of does it already exist? And I know it does exist in a lot of places, but does it exist where it needs to exist? And kind of identifying those gaps would be pretty important. And then when I think of, again, phasing in, and I was talking with Mike Bryson during the break, and I said to Mike, if you had to communicate in a black sky event, who are the first 10 people you need to talk to? And making sure that we're prioritizing that based on need, because we're not going to be able to get everybody on day one. So I think when you look at phasing, you could be going deep and you could be going broad, and some of it may be driven by what's available. And, and also just an interesting conversation on break around some EMP shielded fiber networks that are being built as we speak right now. How could that play into a solution to this? And I know that's not answering the governance question per se, but it's hopefully answering a little bit of the scope and sequencing.
No, that's great. That's exactly what we need. Again, this was just Scott Blevins looking at a map, and this is how we're going to phase it, right? But you guys are really know how to phase it, who needs to talk to who, how can we connect this in. And that's where I really wanted a lot more, audience engagements here, because we have other utilities, obviously, that are here and represented in here, what their thoughts are, or like where you brought up, Tom, like, where does this dark fiber exist? Maybe some of the utilities here, have some ideas about what they have there as far as dark fiber, or maybe where they're lacking. I know that TVA has done a lot of work, just from the discussions we had with Ian, that they've built out a lot of fiber, a lot of EMP-protected fiber across their network. And maybe Ian can address a little bit of that.
I think you got a question.
Susan had a question.
I could turn this on. Hi, Susan Rogers with Sumitomo Mitsui Bank. So that was my question about dark fiber, right? So it's the vulnerabilities around that dark fiber as well, right? We've had really significant, I think the FEMA national exercise we actually talked about breakage of fiber, okay? But then also competition for fiber. Years ago, we were talking about dark fiber for building redundancy, but now you've got the cloud providers, right? You have, all these government critical infrastructure. So I think governance around that, being able to see where your prioritization for being able to utilize and where those weaknesses are.
Yep.
Yeah.
Couldn't agree more, yeah.
Yep.
Go ahead, Mary.
I was just wondering, what were the legal issues that came up when you were initially deciding this? And then is there a legal issue of bringing TVA on? And so is that a key thing that the governance would have to address?
And I'll just take a little bit of stab on that. So, when we looked at connecting these three companies, obviously, PJM doesn't own the fiber. It's owned by Dominion. It's owned by Exelon. So, they had to work through some of the legal stuff of that. And you're actually connecting three companies together, right, into this other network that exists out here. So they had to export through some of that. And we worked through some issues like who provides the routers, who's responsible for the equipment. And we ended up going in this part of it that it just made more sense because PJM has PJM Net, and PJM, they push the routers and the configurations and those things to the organizations that are PJM Net. Let's just kind of follow that model. So in this instance, PJM owned all the routers and stuff, owned the configurations, and it just made more sense to kind of structure it that way, even though Dominion and Exelon actually owned the fiber that it was being passed over within their part of their network, passing it through their equipment, right? Because, I've got a PJM router here, I've got a PJM router at Dominion, but in between are all Exelon and Dominion routers, switches, fiber, all that stuff. So getting the people to agree to leverage their equipment, leverage what they own, getting the cybersecurity guys to be comfortable with that by using things like DWDM and those kind of things to create it at a level that it's not really impacting someone's network. That was a lot of the issues. Did you want to address anything else on that, Tom?
I think you captured it, and at least from my perspective, it was almost like traditional things, like just making sure you had the terms and conditions right, and you had liabilities right, and all those kinds of things, and those were things that just took a little while to work through, and I think you captured the ownership issues and those things. So,
Tom, do you think working through those, could those be exported as a template to other RTOs, or is each one going to be a little, I'm sure they're a little bit different, but how much of that, because you guys were the pioneers, that's the meaning of the pilot, right? But so we've got some lessons learned. What can we leverage going forward, in your opinion?
Yeah, I think there's a lot you can leverage from the pilots, and as you know, as you bring more people in, you're getting other perspectives. So there could be other issues that pop up that we didn't see. But and I think when you look at the governance of it, the way it's going to be successful is if you have a template like you're saying, so that it's like, how do you connect to this network? And there's a set of rules. How you connect, who connects, what are the security requirements? What are your obligations? Everything that you would have in a typical contract. So I think you need like a commercial contract. And I think we could use some of what we've built. And I also think there's other models out there we can apply. But it's a fair question and an important one.
Right. So hopefully, like each piece of that puzzle should be a little bit easier than the previous one as we keep learning and growing the network. And just wanted to mention something to Susan's question, is that in this particular case for the energy sector web, this is dedicated utility-owned dark fiber that runs through it's the optical ground wire. It runs through their lightning protection. So we certainly have cases where some dark fiber is oversubscribed and so on that is within the telecommunications networks. But that's the nice thing about this is it is it's really dark right now outside of a couple strands, and so there's room in there, and the only folks and the fact that the utilities control it and own it is a big advantage.
Yeah, 100% utility owned and controlled. That's what we were going after. And, you know, when they use the technologies like Exelon brought with the dense wave division multiplexing, you know, I can take one fiber and I can push, you know, a whole lot of extra networks down there across that same kind of piece of fiber. So the utilities have a lot of, you know, powerful capabilities and technologies at their disposal to build this out. Ian, did you want to go ahead and address, I think there was a question there about, you know, is there any kind of prohibitions like between like TVA or whatever working within the energy sector web because of the federal aspect of it?
I don't know. I'm not aware of any. TVA, you know, part of our charter really is to be at the forefront of technology for the industry. So that would be kind of contrary to the kind of restriction you're talking about. I'm not aware of any problems there.
Hey, Chris.
Thank you.
Chris, I you know, going back to the question, I look at, you know, I'm going to make some assumptions here, but I don't think it's hurdles necessarily that would be the correct terminology. I think it's just partnership issues. Typical you know, you're talking about a partnership, there's always going to be legal challenges, questions, and then in particular, maybe one of them might be right-of-way issues and easement issues, but I don't look at it as issues more so than hurdles. Maybe that helps a little bit.
I think Chris will give me I only got 5 minutes left, so do I have some other questions out here? Go ahead.
So what are some questions or things we should take back? Because Duquesne Light is in the PJM territory. What questions do I need to take back to my CISO and say, hey, these things are happening on the eastern side. These are 10, 15 question framework things that I need to take and say, you need to consider this, or you should consider this to start talking to about the ESW.
Yeah, I mean, I'll take a first shot at that, and I think the first thing, and this will sound odd maybe, but it's, do you want to solve the problem? You know, do you see it as a problem? You know, that because if other companies are going to, you know, join in on this, and, you know, it's obvious that, you know, Exelon and Dominion and PJM looked at this as, hey, this is a problem that's worth trying to solve. And I know TVA is looking at the same thing. But at the end of the day, you know, that to me is really important. So I think, you know, kind of going back to your company and saying, hey, how important is resilient communications to us to sustain our operation during a bad day? And if we get that level of energy, and that's where I do think the government can come into play as well, because that's what's being said coming out of these grid exercises. You know, is people are standing up, CEOs are standing up and saying, grid communications during an event is critically important. Now, if you don't think it's important, then you're not going to invest your time or your money in it. So that's the first place I would start. And I'd throw it back to you guys if you got anything to add.
All right, thank you. Udi, did you have anything that you wanted to comment on before we wrap this session up?
Thank you.
Let me reach out there to Tom and see if you've got any other last comments.
I think obvious question.
Go ahead, Avi.
Yeah, I have a question, and this relates to something that we talked about, but I think I'll submit a suggestion. I think there's potential here to arrange for an organizing meeting, not a conference, but a meeting of some of the key potential players, maybe summer time frame. That would give us time to poke around, to actually have a follow-on milestone out there. Does that make sense to explore this?
Yeah, I mean, I think that would make sense, and I'm looking out in the audience, and I'm going to put Manny Cancel on the spot a little bit, you know, I would like the EISAC to be involved in that conversation because of the recommendation coming out of NERC GridX is that I think, you know, they're they're our trusted partner in terms of information sharing, and but you guys have been close to people beyond PJM that are suggesting that resilient comms are important. So I'd like to include that feedback because I know there's after actions coming out of GridX.
Yeah, Tom, thanks for that. And, at the end of March, the after-action report for GridX 7, which was conducted last November, will include, again, yet another recommendation about resilient communications. But this time, because I'm getting sick of writing the same recommendation over and over again, is really some clear actions or more clear actions about the steps that we could take. So how can we more purposefully evaluate these and maybe other technologies, or how can we work with you to think about what a sort of expansion plan looks like, right? I mean, we've done this in the sector, right? We've done some big things like cyber mutual assistance, right, where we've gotten past, some pretty thorny issues from a legal and regulatory framework. I'd like to think, maybe I'm being overly optimistic, that we can find a way forward. And I think whether it's what Scott's proposed here or working smaller, or I don't know. But ultimately, though, and I go back to one thing you said earlier, Tom, this is a resource-intensive thing. Everybody who wants to participate is going to have to devote the resources to do that, which I, having been, at a utility before I joined the ISAC, that's always a struggle, right? You have to put the resources up front to sort of do that and think about that. But, yeah, and I mentioned to Scott during the break, and Tom, I'll reach out to you. We'll likely share the context of this recommendation and suggested actions before we publish the report. There will be a webinar that we conduct to go over the after-action recommendations as well, too, so we can share that as well. The report gets published, by the way, it's public. It's on the NERC website, so, I can let, folks here at EIS know when it's published, and you can push it out there. So, thanks, Tom.
Will do. Thanks. Okay, I just wanted to reach out to Ian, see if he has any last comments before we wrap this up. Okay, I think we had a really good discussion here. This panel seems to go by really quick, and I know there's a lot more we have to address here. One other thing I did want to mention about this is we worked to put the energy sector web up on the EIS website that kind of addresses some of the stuff, talks about some of this stuff and everything like that. So if you get a chance, go out there and check it out on the EIS Council website under the energy sector web. And, we're looking forward to any recommendations and stuff like that on how we can improve it and move forward on it and can collaborate. Thank you.
All right, thanks, everyone. We'll take a break and come back at 10 after 11. Thank you. I'll invite those folks to come down.
Chaos.
And Udi, you're chairing this one, right?
Right. No.
Yeah. Yeah.
Okay, the Chaos Management Panel. It's a very intimidating title, but indeed, so it happened that all four of us speak fluent Hebrew, on the right of the fact that our English is a little better than your Hebrew, collective Hebrew. We'll try to conduct that panel in English. Imagine any black sky scenario. It is a chaotic situation. And the way that, before I get into that, let me introduce Avner. Avner Chilu is the Genome Program Manager. Yossi Schneck has got many, like almost 50 years experience in the electric sector at IEC. And Nomi, who had been yesterday as well on the panel, is the head of the Power System Dynamics Department at NOGA, the newly established Israeli R2eP. And without further ado, I'll please ask the next slide. The next one. Okay. Genome, it's the Global Infrastructure Network Optimization Model, is a tool that we're currently developing for helping emergency managers to manage a chaotic situation. Next slide, please. Now, when we speak of the 5 pillars of societal resilience, again, I'm going back to Emergency Management 101. There are 5 stages. Genome can become helpful supporting all 5 stages, but mostly in a recovery from extreme disaster. Yesterday in the panel, Budge mentioned Turkey, the earthquakes in Turkey. So imagine that communication is down, transportation is unavailable. You've got to deal with, I mean, I was impressed by the number of, I knew about tens of thousands of people killed. I was not aware of the 1.5 million people injured in the course of that disaster. So imagine that you have to deal somebody like Budge or Budge boss has to stand up and take decisions in the recovery stage with very, very limited information coming in. So we believe that Genome is a very critical decision support tool in the recovery stage. What it is, It is a large-scale network native, multi-sector simulation operating system. And the emphasis here is on the simulation tool, because in most cases, you refer to what you know. What you know is based upon what you have experienced in the past, and you try to draw conclusions, getting the limited information which is available, and that's not genome. Genome is actually a tool that is based on ability to simulate the event. Imagine now, we spoke yesterday about the silos, critical infrastructures, electric, water, transportation, health. Each one has got within its own silo the tool that provides situation awareness. Now imagine your phone. On the phone, in the phone, we've got a lot of applications, but we've got an operating system that allows all those apps to communicate and support each other. So that's, in a way, genome. Genome is the operating system that is supposed to be fed by information available in a siloed mode and be very helpful in integrating and driving the right decisions. Currently, we're developing a genome for all those listed critical infrastructures. And imagine a FIFA application where you have players, and each player has got his own capabilities. It is all being modeled, and the interrelationship between all those players is useful in that simulation. Now, it is GIS-based. That's just a picture of all the available information in Israel of 21 different sectors. I mean, GIS data is available all over the world. We are able, or we hope to be able to model all the sector supply chain relationship and the dynamic behavior of which one of the players, and that allows an event simulation like large-scale infrastructure collapse being the essential capability to support society. The word digital twin is used everywhere. So there's no other word that I can explain what genome really is. It is a digital twin, but it is patented. I mean, the basis for that is patented in the patent that allows us to manipulate a huge quantity of information in a very, very effective way. Where is genome today? I mean, genome is not available. I mean, I can't take purchase orders. It's a TRL 3 to 4 being funded by the foundations that support EIS Council and by the Israeli Ministry of Energy. It wasn't too hard to convince the Ministry of Energy that your system needs such a tool. As you know, I mean, I truly believe in videos, so I'll try to run a video, a short video that will give you the flavor.
We're going to run the simulation for Los Angeles. This is what would occur to the city center.
We need to increase the volume. There's some way we can... Folks behind the screen, can we increase the volume and go back to that demo? No, that's not me. No, go back, there. Let's see, let's try again. No. Can
you please run it from there with sufficient volume? Okay.
We're going to run the simulation for Los Angeles. This is what would occur to the...
We could hear it out here, it just needs to be a little louder.
Once again.
We're going to run the simulation for Los Angeles. This is what would occur to the...
Sorry about that.
Just go through it and talk through it.
Okay.
We're going to run the simulation for Los Angeles. This is what would occur to the city center immediately following an EMP strike. We see the electric grid go offline. COM will start shutting down as backup power fails after batteries and backup power resources are drained. With increasing signal outages, slowdowns turn to gridlock. Within about 3 days, water will have stopped flowing in much of the LA basin. Trucks can't refuel. Food, medical supply, and pharmaceutical distribution will begin to fail after a few days. Operating hospitals become overwhelmed. Some urban fires start erupting, and limited water availability to put out the fires. Big concerns for military bases that depend on local resources. Security concerns, national defense issues. Here you can see how this expands to cause a regional shutdown. Casualties and loss of life would escalate relatively quickly. Now, in this simulation, there has been significant prioritized hardening, especially in the power grid. Organizations here have good emergency cross-sector coordination and at least basic situational awareness and decision support capabilities. As you can see, after the power goes out, cascading failures are limited. Restoration efforts begin fairly quickly. Very few casualties and loss of life. And cascading effects on the surrounding regions would be significantly reduced. A large segment of the population could have power restored on a limited basis in a day, and the majority of the population within a few days.
What we saw here is using genome as a planning tool. I mean, we've got two scenarios. One scenario is no EMP hardening across all of the critical utilities. And you saw on the upper right-hand side, when we fast-forwarded the situation over 72 hours, the bottom box was the number of casualties in the hundreds. And then we ran again the simulation with hardening and with inventories in all critical infrastructures, and you saw that after 72 hours, number of casualties and number of shutdowns was much, much lower, and the recovery was much faster. The way that we envision the tool itself being used by emergency managers is as follows. This is what you're going to see on your screen when genome is activated. On the top, can you stop for a minute, please? Sorry about that. Okay, Avi, I'm sorry. I mean, we'll run it through, and I'll try it. Now.
Go back.
Huh? Okay. Now what? Now what? All right. Okay. So what you see here on the top line, the first thing that happens is a visualization of the damaged infrastructures. And then there's a list of all the alerts that genome generates as a result of information coming in from the thousands of players in that simulation. And those are the alerts. And then genome sends inquiries to different agencies and translate that to the level of danger. And then the most important part are the recommendations. the recommendations that genome generates that tells the person in charge, these are the 5 or 6 or 7 actions to be taken immediately in order to recover as fast as possible and with a minimum number of casualties. Obviously, this is where we're heading. Again, it's not available right now, but that's where we're heading. As I said, I mean, we're currently funded and moving forward with a little team of developers headed by Avner, and we committed to the Ministry of Energy in Israel that next summer we're going to play side-by-side genome with the national emergency exercise that NOGA, our national RTO, will be running somewhere between May and June timeframe. And I'll leave questions after I ask my colleagues to share with you their thoughts. And Nomi, let's go back to what's going on in Israel and share with us some lessons learned during the 4 months of the ongoing war. What are the implications on manpower, damage and repairs, and inventory that was discussed previously, and other policies that you have changed as a result of those 4 months?
Thank you, Udi. I must say, first of all, before I begin, it's really my pleasure to be here, and I enjoy every minute, so thank you. I will share with you some lessons that we have learned about. I will talk about fuel inventory planning, equipment damages, equipment inventory planning, desalinated water production, computer and cyber considerations, and manpower. I will try to explain in brief those lessons that we have learned. The first one is fuel. Natural gas shortage may happen when there is a risk to the gas rigs in the Mediterranean Sea. Because if there is a war or any case that we are afraid of terrorism, then we will stop the rigs. As natural gas will be the only fuel we will use in the next years, except renewables, of course, it is a very significant issue. So we demand that each big generator unit should be dual fuel. So they should be able to work with secondary fuel in case there will be no gas. This transfer from one fuel to another is being practiced periodically, and it can be done without stopping the generation unit. So we practice it and we think about it. We also making simulation, calculating the line pack, because you know when we stop the gas from the rigs, then there are still natural gas in the pipes. So we make simulation, we prepare them ahead, and we make simulation in order to decide which will be the first unit that we should transfer to the other fuel, to the secondary fuel. In that way, we will not miss any, we will not have to stop each generation unit. It is very important to preserve our coal units. We were speaking about that also yesterday. That were supposed to be retired at 2024, but hopefully if we succeed in preserving them, so they will be ready to come back to work if and when we will need them. We also have some other coal units. We have those four units that are going to be preserved, but we have also some more coal units that we are just transferring them to work with natural gas because they are better for the environment. but they will be still able to work with coal. So if we will need them, if we will have shortage in natural gas, then we would like them to go back and to work with coal. So we keep on our coal units, but they will work from time to time, and hopefully it will succeed, because if you don't work a unit, then you don't know how it will behave when you need it. So hopefully we'll have them. Getting the decision for how much diesel and coal we should keep for natural gas shortage must be also calculated in advance for the different emergency scenarios, because now war becomes longer, and so we should calculate very carefully how much fuel inventory we should keep for each kind. We should give a lot of efforts to connect the big generation sites to diesel pipes, so there will be no need for fuel tanks in transportation because we can't rely on transportation. So until now, we don't have diesel pipes to each of these generating units with secondary fuel, which is diesel. And I think that we might build our pipes so they will be independent and not dependent on the transportation. Regarding damage to equipment in substations, each substation should be examined for possible risk, even not direct risk, like blast damage resulting from gravel scattering everywhere, for example. I just mentioned this one because that's the only one we had in this war, because one of our important 400 kV substation had this failure, and it damaged the equipment. Speaking with the Ukrainians, they recommended minimum usage of GIS substation, which is a gas insulated substation, because it takes a long period to repair them, because they are tailor-made and you don't have spare parts to replace. So they suggested if you don't need it to be GIS substation, then don't do it, do it air insulated. They are much faster to be repaired. We can harden the substation with thick walls, for example, surrounding the important particles there. We can use also active protection. It can be relevant sometimes. And we are still asking the Ukrainians what they learned from their war. So they suggested the primitive solution of huge sandbags surrounding their transformers, for example. And they said this was the best solution. Important substations may have already been planned in the plan stage to be more resilient from the planning stage, and maybe built, for example, we can build them underground if this is supposed to be a very important substation. Or maybe we should build it with spare field, so if one field will be out of usage, then we can use another field. It's all costly, but sometimes we think that resilience must be in our criteria of design, of planning. We should identify those important substations periodically because the system is developed. So we should follow the system development and decide each time to do calculation which are our important substations. Inventory, I was just answering yesterday Craig's question, but I will try to add some things. So the critical elements should be identified. First of all, we should identify which are the critical elements we need. Risk assessment calculation can indicate the number of spare parts of each type that we need to hold in our storages. If there is a massive development, as we have now in Israel, mostly because of renewable penetration, then these stocks might be considered as an advancement of investment, and that makes it more economical. The biggest problem is with transformers that have a long production time and have about a year-long queue. In addition, step-up transformers that are for generators are not similar for different generator units. Each generating unit has its own voltage and its own rating, so there are no spare parts in this kind of transformer. So this is also challenging. Even though it is not economically feasible, we may think of producing these critical elements locally in our country. We had a transformer factory that made transformers, also 400 kV transformers in Israel, and the investors just took it out of Israel because it was not economically worth to remain in Israel. So maybe we should just not just look at the economical point of view, but we should have some very important infrastructures made here locally in the country. Now the latest transformers we buy are from Turkey and from China. And they're not our best friends this time, so this period, so that's where we are. I must admit that for commercial reasons, I think it was difficult to get the inventory information from the different private producers and even from the Israeli electric company. So I hope this will be changed for the next event we will prepare to. Desalinated water. There are some generating units that need desalinated water only for reducing the pollution they make. So if that's the situation, so we can give up and not have this desalinated water in this site, because emergency is compared to environmental reasons, so we can maybe give up. But if sometimes desalinated water are needed to operation, so in this case, we should have enough quantity that will be generated in the generation site. Because nowadays we define some inventory of desalinated water, and they just bring more desalinated water by trucks. And as we saw and as we know, we don't have to rely on transportation. So if we have a big generation site, we should be assured that all the desalination factory will be on site and not transported by trucks. A computer and cyber, that's a big issue. Maybe Yossi will speak about it later. But also something very primitive. The enemy knows where we work and where is our centers. So if they will attack our centers, there might be problem with the computers themselves. So we thought that we should put all our computers in some very safe place and just remotely connect them. So we took our computers out of our offices just in case they will be attacked. It's a simple thing, but maybe sometimes also we make backups, of course, but it's a simple thing, simple thought, and it was a new thought. It came up in the war. We also can't go, even though our computers are not operational, but just for doing simulation and management, we can't get into the internet in our computers at work, just to make another kind of cyber envelope, not to put more risk in the system. So there is much more done in this area, but I will not go to that. Last but not least is manpower. 40% of my workers in my department were called to the army, and from the 7th of October and until this week, they are still didn't come back. It's 4 months. In case Hezbollah will start a war, they will be called to go back because they are already practiced for that. The situation was even worse because the schools were closed for the first period at least, and the mothers had to remain at home with their children while the husbands are in the army. So the women didn't come to work, the men didn't come to work, so who will do the work? And meanwhile, we had to continue with our work and even deal with some new urgent assignments. So we had more work and less workers. The main implication is that we should assure that at least there are 2 people who overlap with their skills and knowing how to perform the division's work. Moreover, we should examine these overlapping workers from their availability in an emergency case. So you can't have 2 young people doing the same overlapping because they will both go to the army. So we just have to think and to put it in our mind who will remain and work when there will be some disaster. Another solution that is, I assume it's well known, is if there is someone with unique knowledge, is to define ahead who should be tied up to work and will not be allowed to leave and go to the army. So this is a well-known solution. And if I prepare myself for the future, so I think we should prepare alternatives for alternative generation units, like mobile generation units, with the mobile step-up transformer and some hybrid field, like which contains circuit breaker and all what is needed to connect it to the system. Then we will prepare some sites that the mobile generating unit we will bring the cabin of the trailer, and we will take it to another site we prepared in advance, and it will be just plug and play. We will have fuel, we will have desalinated water, we will have the connecting, we will know how to connect it to the system. So if we will prepare it ahead, we will be able to move this unit. Maybe they are small ones, but it's better than nothing. So we can move them around the country wherever we will need them. There is another solution that we were examining, there is PowerShip, that have its anchorage sites somewhere near the shores, and they just put the cable or transmission line and get into our high voltage transmission line and supply energy. We are speaking about 400 kV, 400 megawatts electrical generation that is coming from the sea. And this ship we can prepare the sites, and we can put it, connect it in the north, in the south, in the center of the country where we will need it. So this is a new solution that we were just examining during this war. As I mentioned, fuel is a very important issue, so for the future we should keep the availability of diverse fuel types, even though some of them are not so environmental, and store enough fuel inventory just to think for how long and how many we should have. And if we're speaking about further future, then we should prepare the electrical system to work in some islands until restoration is achieved, using renewables and grid forming. Hopefully they will be active and work okay, to have these grid forming batteries that may also give us a black start. So this is for the further future. I think these are enough implications to start with, so thanks.
Naomi, thank you. I mean, this is really a nice explanation of what chaos really means and how to deal with chaos. Yossi, 2 weeks ago we heard an eye-opening presentation by Mr. Tsimbalyuk from the Ukrainian grid DTEC. Can you share with us your notes of differences and similarities between what's going on in Israel and what the Ukrainians have been witnessing for the last 2 years?
Okay, so I have to admit that actually I'm assisting Ukraine from the beginning of the crisis. I do it short, Greg, don't miss. And I have to say one thing, even though we heard from Jan, that is my very good colleague, and I'm working with him for several years, at least very intensively from the beginning of the crisis. Actually, Ukraine was totally not prepared. This was the situation. Today, actually, we hear how they overcome different obstacles and everything, but they were totally not prepared. But what happened, actually, I call it, they have kind of unintentional redundancy. That was actually based on the original traditional Soviet Union planning, okay, that according to our measures, there is no efficiency measures, there is nothing, there are different goals. So, for example, suddenly, if we have, for example, maximally 2 feeders that are going and supplying electricity to some point in the network, they have 5 like it, okay? So on the technical situation, even though significant part of their infrastructure was actually destroyed, and in the worst case, we are talking about 70% of the infrastructure, at least of the distribution system, was destroyed. They still have enough redundancy to supply, in most of the cases, at least few hours a day, electricity to the industry and to their citizens. So this is the electrical or if we're talking about supply chain, at the beginning, they didn't have any spare parts or very low spare part availability, but because of the unintentional redundancy of the systems, they were able to dismount many of equipment that were not actually damaged and move them to the places that they needed. After about 5 months, actually, the different countries that decided to assist Ukraine in the crisis started to support them and bring additional customers. So this is additional thing that is they have to thank to the big Soviet brother. The third thing is actually human resources, because you are in war. A lot of people are also in Ukraine in the army. A lot of are unable to work. So what happens then? Again, you know, I was born and grown up to some age in the communist regime I was born in Czechoslovakia. So actually what Soviet Union and the communists say, there is zero unemployment in our country. So how you reach zero unemployment? You put in any place that you need 5 people, you put 50. And in this situation that happened, actually they have a lot of professionals and people that were able to assist, even though many of them were missing, they have still the main source redundancy because of those things. And the last thing, because I see that Chris is angry already, the last thing is actually, you know, there is also kind of what I call it a social level expectation. The population of Ukraine, even though Ukraine in many parts is a very developed country and industry, there are a lot of parts that the population does not accept a higher level living and prosperity as we in Israel, and I'm sure in the States, are. So they were actually more able to suffer the situation that suddenly they have only 5 hours of electricity or 6 hours of electricity until it was recovered. And I have to say that Nomi mentioned different additional things. For example, what technology is better to have, like not to use GIS substations and many other things that actually they learned during the war, and they are sharing it with us. And I think we should all learn from different things. But as I said, sometimes you have to have things that are not intentional, but very helping you to overcome such a situation.
Thank you, Yossi. Disregard the clock, please, Avner.
I will try to do it shortly.
Avner joined us a few months ago, and he's the Genome Program Manager. And please share with us what are your plans for the next 2 years until we deliver actually what we promised Nomi at NOGA and beyond.
So to start with, it's a really exciting project. I've been in high-tech for 30 years, working with many companies before, and this is, I believe, the most challenging and exciting project I ever been a part of. So this project started with our technical director, Dr. Anthony Bucci, which is started as an R&D project. Like we were trying to simulate the electrical grid and place it into a simulator. So when it worked, and we continue to the other phases, we see it as one of the major challenges, take it from an R&D project into a product. And this faced some challenges. For example, how can you import so many objects into a simulator to simulate the electrical grid of an area? So when it's an R&D project, you take a small portion of objects and you can simulate and play with it and everything works fine. But if you try to simulate the entire grid of Israel, for example, it's much more challenging to upload this entire data into a simulator. So we need to stand up for security regulation, privacy regulation, and have the ability to upload large files with tons of objects into the system. So we are developing right now those functionalities for manually importing large scale of objects into Genome and to have an API so we can get data in a real-time manner. So this is one of the challenges we are currently working on. The other one is to provide a decision support function. So we would like to run a simulator based on the entire object that we have in Genome, and it's not just bringing this object into the system, they have to perfectly be aligned with each other. So it's like a huge puzzle that you need all the pieces to fit in order to simulate a grid. And we would like to do it on multiple sectors, so it's not going to be only electricity, it's going to be other sectors as well. So to provide a simulator, a prediction of a black sky event simulator, we need a proper user interface that we can, lay out a scenario, and then to have the Genome engine running and simulate this event and give us prediction. So, but we don't want to stop there. So we can have the prediction what's going to be happening if this event is gonna occur. And I think that after listening to everybody here in the panel, it's gonna be an eye-opener to show what's gonna happen if a major or a black sky event gonna take place. So you will have a utility to show this is what's gonna happen, okay? So, but we don't want to stop there. We want to continue further and to provide suggestions how we should handle this challenge. So if we have a black sky event, what would be the best way to handle this event? Okay, and this was also brought up in a lot of panels here. How do you prioritize what you are going to do first? Okay, so we would like to do this. And we don't want to stop there. We would like to provide also recommendations. So let's say that we have prediction of a black sky event and we have some sort of, this is the best path we believe you should follow in order to handle this challenge. But we can also provide recommendations saying, if you will improve, for example, the manpower, or you will have more fuel for some sectors, or will increase your first responders team, you might have been handled this situation much faster. And so we can provide some recommendation of how we can improve our teams to handle these channels. So this is another major sector that we would like, challenge we would like to handle. So this phase is an enormous challenge because the complexity is amazing. So when you think of one grid of for example, the electric grid is a huge challenge by itself, but when you would like to see how every sector is going to affect another sector, it's become a very complex challenge to handle, and then you would like to also provide recommendations and predictions for that phase. The last thing I would like to add that we would also like to take some other simulators' results and integrate them into Genome so we can learn much faster about how a different simulator predicts what should be done and what we suggest. And there, the system can grow up and learn much faster. So there's a lot of challenges ahead of us. We're a small team, which is also a challenge. but exciting times.
Sorry, we ran out of time, but Avi want to make a comment.
One very brief question. Does this require proprietary information from each of the sectors to operate?
We are trying to avoid having, you're referring to the data that we are observing into genome, right? So we're trying to keep it as limited as possible. So we require a limited amount of data from the operators, but we do want to stand in any way for security and privacy regulations, so it shouldn't be an issue for us to import this data in.
Yeah, but the key, as I understand it, is it uses only functional information, correct?
Correct.
Whatever level of detail is required, but functional only, so no proprietary data.
No, we shouldn't hold any.
That is, I think, important to clarify.
And another comment, we would like it to be, as Udi mentioned in the presentation, a standalone operating system. We cannot rely on any cloud services to run genome, because we would like it to become eventually a real-time tool for decision making. So if you are a stakeholder or you need to decide what you need to be doing now, right now, then if we absorbing all the data within the simulator, we can provide a recommendation in a real-time manner. And we cannot rely on any cloud services or any other thing that out there. We need to rely only on the information that genome holds.
Okay.
Avi, just one remark. Avi, if you allow me, actually about the data, first of all, you told one of the things is actually it's functional data and not a proprietary data. Second thing, actually, even though we are talking about simulation, we are not needing to actually import all the detailed data as are in the operational program like EMS or DMS or all those things. And this is also kind of, I would say, smartness and to do something that you have less data and still get accurate results to good for decisions.
Yeah, sorry to admit, I was the worst moderator of all the panels so far. It's 8 minutes overtime. Chris, excuse me. There's a lot of questions, I'm sure. So, but we're going to be here through the end of the session. Thank you, Nomi, Yossi, and Avner. And Chris, it's yours again.
All right, thank you. Thanks to the panel. Yeah, please find them during lunch. I'd like to bring up Brigadier General Michael Lowell. Apollo is his call sign. He's the director of the Electromagnetic Defense Initiative at Joint Base San Antonio. I'll make a quick announcement. We do have to break for lunch at 12:30 because there are other groups besides us. So on the agenda, we were going to have Brigadier General Lowell and then Yossi Schneck. I think we'll just wait and pick up Yossi's presentation right after lunch. So the floor is yours, Apollo. Thank you for being here.
So let's see if this is turned on. Are we hot? All right. Hey, so first, thanks to the EIS Council. Thanks for PJM for hosting. Thanks to Dr. Beck for the invitation. And thanks, Dr. Beck, for putting me the last thing between lunch. But hey, so I've got a good news story here I want to share, but I also want to encourage you, as whether you're an infrastructure owner, part of the industry, whether you're part of R&D, or however whatever brings you to this forum, beyond the technical solutions and the equipment solutions that you may be looking for resiliency, I want to ask you to open your perspective a little wider to how to leverage the community in and around your operations for resiliency. So on behalf of Joint Base San Antonio, it's a pleasure to be with you today. And I want to share the story about, slide please. I want to share the story about San Antonio electromagnetic defense. Quick soundbite about how I found myself in this. I'm a Texas Guardsman by trade. Thanks, Chris. So Texas Guardsman, CPA, from Price Waterhouse Coopers, the Coopers legacy side, and found myself where we had a need in San Antonio to really examine the art of the possible for resilience. So 2019, I joined the program. It's relatively new. I do see friends in the audience that I've met at other engagements, so it's great to see you again. But for those that I haven't met before, I look forward to working with you and collaborating with you. So slide, please. So the mission of San Antonio Electromagnetic Defense, next slide, please, is to ensure joint base.
Go ahead and push the green button on. Yeah.
I like being independent.
Oh, okay.
So there you go. The mission of our program is to ensure Joint Base San Antonio continues military ops in a post-EMP environment. We do it from an all threats perspective, a HEMP, high-altitude nuclear weapon, a geomagnetic disturbance being natural. We look at it from physical threats. We look at it from cyber. So bring all those domains together. We're in the active preparation for a bad day. Think of it in that respect. In doing so, we've created an EMP resiliency model. I'll show it to you on the next slide. It's ready to export, scale, and apply across DoD and elsewhere. DoD is actively applying it. To support a dissuasion campaign, to allow our enemies to understand that EMP is not going to be a viable weapon against America. And then thirdly, we use 5G as well. We're looking at how the Internet of Things affects us in this, whether it's good, bad, or indifferent. And where possible, we're applying techniques from AI, ML, different data analytics to inform the decisions and risks that are applied. And with this, we got the push button just right. This is the model I'd propose to consider as you apply the strengths of your community. From left to right, center screen, you'll see a military patch. That military patch represents a 4-person liaison team that I have the pleasure of leading for Joint Base San Antonio. But really, what it has is 4 lines of effort. The top line of effort is indicated in that first bar that goes across. It's infrastructure. The second is 5G. Third is policy and education, which is a very viable product to increase resiliency in your locality. And then fourth, recovery readiness. Think of emergency management in a bad day when no one's coming to help you. Those bucket trucks aren't coming across the state line from neighboring locations because they're rebuilding organically as well. The magic of this model, through the authority of the base commander, Brigadier General Russell Driggers, who's shown in that first column or almost center screen, is that we engage the public through a public-private or P4 relationship. We meet quarterly. I say quarterly. It's turned into more like 4 or 5 months intervals now because we've got heavy program management responsibilities. And we meet. And the true energy and magic of how you get your community invigorated, how they take ownership of resiliency, is to create work groups and steering committees. So work groups are shown just right of center screen. We have work groups for each of the different lines of effort, not shown as steering committees. We've got steering committees for each of the work groups that really helped us in the strategic planning. We mobilized the leadership of the community, those folks that were early adopters of resilience and early adopters of how to apply the best techniques and how to overcome some of the roadblocks to collaboration. So we heavily leveraged strategic planning in the effort. And then the deliverables that we're going after on LOE1 or infrastructure, we're talking power, water, waste, gas, transportation, communication, the whole gamut of infrastructures we want to have exercised, planned, and resilient. In 5G, we'll show you where we're at right now. We just finished up a 3-year program for the Office Undersecretary of Defense for Research and Engineering. We did telemedicine in 5G and 5G core security. In the third line of effort, we call it DIMSO, or if you think electromagnetic spectrum operations that the military is pretty good at, add a D for domestic in there. That's what gets you into the quality of life and what keeps us out of operating in the Stone Ages. And then finally, in the emergency management or recovery readiness, that bottom line of effort, we've got a deliverable that we're really proud of. We went well beyond all hazards planning for EMP and created an annex specific to EMP planning for our base. So let's dive into that just a little bit. For infrastructure, on the strategic planning side, many of you that have had military experience before or interacted with the military, you're familiar with combatant commanders, combatant commands, right, whether it's geographic or functional. Joint Base San Antonio is by and large a training base. We do have quite a bit of operational capability in the cyber and intel side, but by and large it's a training base. So we're not a combatant commander, we're not a big R requirement, if you will, for EMP resiliency. And really the art of the possible was blended into our program. And what we wanted to demonstrate is on EMP resilience, there's ways to go after it that are far more economical than the traditional ways that the military has used. Those are extremely expensive, they're hard to scale, they dampen our operations, and that you really don't captivate on the true strength of your organization, being your employees, your staff, your operators. So from a vision statement on infrastructure, we wanted to demonstrate the art of possible against a holistic infrastructure resiliency program, and ultimately always keeping that mission statement of keeping mission operations first and foremost. We went through the typical risk management approach. We identified our critical assets. We prioritized them. We wanted to partner with our infrastructure owners. And then we wanted to be part of the national program, the Presidential Executive Order 13865 on EMP resilience that was put in place by the prior administration and ratified by the current. We're the only non-ditcher element part of DOD that is in this Presidential Executive Order as a pilot. We've moved that forward, and we wanted to get some quick wins, if you will, on things that people talk about, but you don't see in practice that much. So Winter Storm Uri changed a lot of South Texas operations. A few years back, 21, it was cold. For people on the East Coast, you'd say it really wasn't cold, but in South Texas, where you have slab foundations for residential properties, and you're highly dependent on natural gas for energy generation, that winter storm with the 8 to 10 days of ice was a tough event to endure. And because of it, resiliency grows in concern not only by infrastructure owners, but customers. So if you talk about expectations for customers, it really moved the ball to focus on infrastructure resilience. And so in so doing, we were able to apply 2 different state grants for resiliency. The first we had actually started in 2020. It was through the Texas Defense Economic Assistance Adjustment Grant. It was a $5 million grant matched with 4.2 from our energy provider, being CPS Energy. And we physically hardened all the substations supporting JBSA. So when you say physically hardened against what? We did it against a Metcalf style event. So a rudimentary way would be kind of the sandbag type of example. That would give you some level of resiliency from the physical threats. The top image there on the left of the screen shows one of our substations that has now been physically hardened. It's got a pretty healthy concrete wall that goes all the way around it. There's as much in the ground for foundation that there is above ground that's visually shown. Inside of the substation, there are different layers of protection. So when you get to those critical components, they have increased protection. And then there's different sensing and cueing devices on there as well. So should an event take place, it helps get law enforcement or a response party directed. In the bottom image, on water resiliency post-Winter Storm Uri, water resiliency was our #1 takeaway lesson learned. When you start talking about life, you start talking about hospitals, medical care, things of that regard, water is the driver. It's also competing with data centers. So when you start talking about different tools that we need to keep America safe, data centers are a big consumer of water for their air conditioning and different environmental effects. So the water pumping station supporting JBSA, Joint Base San Antonio, we're increasing the resiliency of them with added backup, both in capacity and power. Move it forward, we're also part of a federal program the Air Force is sponsoring at Joint Base San Antonio on geothermal. Geothermal, you don't really traditionally think about down in Texas. You think about it more in the ring of fire that isn't in South Texas or Central Texas. You might think of it out in the West Coast somewhere. We're one of 2 Air Force bases as part of this, and over an 18-month period, we went through the research that that the industry was saying geothermal is ready for prime time in America, so we've got a prototype that's underway. We put it on contract in September. And the next slide, I'll show you the team that's putting that forward for us. And we expect a production facility size plant within 5 years. That's fast. That geothermal pilot will give us resiliency for what's at the top of that screen, the POL, or Petroleum Oils and Lubricants Facility. It's a 2 million gallon JP8 or jet fuel complex. Each tank that's shown there on the image holds roughly 1 million gallons apiece. It also supplies fuel for a cargo plane wing, an Air Force cargo plane called a C-5, or the largest cargo plane in America. A wing at San Antonio is dependent on this fuel. So if we have to rebuild organically, we want to make sure that air bridge is supplied with fuel to get those necessary supplies to rebuild America. Moving along, this is the team that's making geothermal possible. We want to be able to prove through a team of the willing in San Antonio that if geothermal is ready for prime time, and you can do it in San Antonio, you can do it anywhere. So much of what we're doing on this prototype, we're not only just going after trying to prove the technology is viable, we're cataloging every lesson learned in the process and sharing those lessons learned. Our goal in the output of this is to have dependable, renewable energy. In doing that, much of our program is looking at long-term for resiliency. You need to be able to have not only dispatchable power, but you need to island that power. So our 5-year program is to get geothermal in place. Our 5 to 10-year program, or the one that's a little bit longer lead time, is on new nuclear. We see small nuclear, small modular reactors, microreactors and beyond, very much the future for American energy. And you're going to see an evolution that talks a lot about new nuclear. The industry's coming online. They are going through some, I'll call it growing pains, but it's very much a viable technology that if you're really looking for dispatchable, resilient, 24/7 power, I would encourage you to keep that as part of your consideration in that portfolio. Time's going to get tight, so I want to just go quickly through 5G. 5G, we did the strategic planning much in the same way we did our infrastructure. We worked a program with Ms. Heidi Hsu for the Office of Undersecretary of Defense for Research Engineering, had about a 25-person PMO, and we developed the prototype outputs that we were charged with. In the telemedicine, think heavy on visualization, augmented reality, training programs, things of that regard. And then on the core security, we got really, really heavy into splicing, management network, orchestration, nanotechnologies, and things of that regard. Shifting gears, now we're more into an operational 5G program where we're bringing FirstNet, built by AT&T, onto our base. You may say, hey, is that EMP resilient? The answer to the question, it's not. But it helps cover much of our installation that has no cellular coverage, slow throughput, things of that regard. AT&T is bringing tremendous infrastructure through FirstNet. It's a 2-year program. We're well into it. We're right on track to be FOC in July of 25. And you may ask, what's really being installed in this process? What we're bringing is about 7 commercial-size, 150-foot tall antennas. Those antenna systems will get those areas that lack coverage right now, and then for those areas that do have coverage, but perhaps not at the speed that we need for relevancy, we're bringing in 15 centralized radio access network antennas and a load of fiber optic. So that program's well on its way. Here's where I really want to spend just a couple of moments. Chris, I know we're getting tight, and lunch is important. But on the policy and education side, most people, you know, when you start saying policy, the eyes roll back, and it's like, so what? But I found if you can tell a story, especially on public engagement, of why electromagnetic spectrum is so important, people get it, and all of a sudden they get charged to do something about it. And in this quick illustration, if you wake up in the morning, your alarm goes off at 6 o'clock, you see the LEDs, you know, bouncing that red light at you, you're hearing the audible behind it, you roll over, you pull back the cover, you go over to your fish aquarium, you feed them in the morning, you happen to open up the shade, and there's a little bit of light that comes through your aquarium with they cast an image on the wall almost like a rainbow. You walk down the stairs, you turn on your news source, whether it's a radio, TV, or others, to find out what the weather of the day is going to be, what the sports outcome was from the night before. You open up the fridge, you pull out your breakfast burrito, you open the microwave, you pop it in there, 60 seconds later, bing, you open the microwave and you pull your breakfast burrito out, it smells wonderful, you grab your coat, you go to the front door, you're out, you see the sun. In that short scenario, that 20-minute scenario, you've interacted with every waveform in the electromagnetic spectrum. It hits us in our quality of life. It hits us in that Western expectation of what life is. So the electromagnetic spectrum is key to our success to be able to stay out of the Stone Ages. This visual gives you a mission assurance graphic that shows the columns or the lanes where the military versus the community really operates. So on the purple column, the defense and military side, you see the graphic for whether it's bombs on target, aviation resources, other things like precision fire, artillery. Those things in the IMSO arena, the military is known for. The Joint Electronic Warfare Center in San Antonio is, they're the lead for it, and they do a wonderful job. But when you get to the green column and the blue column, the green being commerce and business, real-time inventories, just-in-time inventories, stock trades, all these different electronic transactions, they're all dependent on PNT, or position, navigation, and timing. Position, navigation, and timing, when that fails, what do we have to back it up? When you think about comforts in modern life, it's more than the remote control to get into your neighborhood or your garage. It's how do you keep from having to basically cook raw meat that was just slaughtered over an open fire? How do you preserve food? How do you keep the food chain operational? So that green and blue column, we added the D in front of, called it Domestic Electromagnetic Spectrum Operations, and that's the program that has been part of our educational and outreach campaign. In 2022, we issued a book that took about 2.5 years to put together. The team that's visualized in the bottom, comprised of about 8 PhDs, and a series of people that came out of industry and academia to help us with this program, resulted in a booklet. We call it the DIMSO 2022 Resiliency Guide. It's got 15 low-cost, no-cost recommendations to bring resiliency at an individual, community, and operational level. The guide is ready now. You can download it from the link. My slides are available. Chris, they're welcome to share. But that link, you can download it now. Northcom has looked at this booklet, and they say it's a benchmark. It's ready for export now. The National Governors Association has received it as a benchmark. But what's really neat behind it is more than just the 15 recommendations. The Rubik's Cube that's shown in the upper right, it's a resiliency model that takes an operator, an organization, or an individual from wherever they're at in that resiliency continuum, and it gives them the next steps. So one of the programs the Army had was under a program where they went out and looked at the SCADA systems through the Jack Voltaic exercise program. And they would go to a city, pick a city, they would go to that city and they would basically red team the SCADA systems there. Roll the clock forward 3 years, they'd come back, and it was almost reissuing the same report time and time again. What they found was the operators, the infrastructure owners, it wasn't their lack of commitment, but it was their lack of knowledge of how to do it at the next level. So this resiliency model was built by Dr. Greg White out of the University of Texas at San Antonio, and he adapted a cyber resiliency model into EMP resilience. And that model is really the magic behind this resiliency guide and the 15 recommendations that are based on NIMS programs. Moving along, most people ask in the afterglow from a presentation like this, how'd you get buy-in? How'd you get traction to do a bottom-up approach to a resiliency program? It really goes back to those steering committees. It's how do you get a knowledge leader that's really, I'll call it a champion, integrating into the community fabric, into the business fabric of the community to say, hey, how do we drop these firewalls between us so that we can collaborate and make this an economic engine that's a resilient engine and also provide safety? That's really the magic sauce behind all of what's written here. The dedicated coordination cell as opposed to a periodic or an additional duty cell is good. That P4 is the mechanism we deploy it with, the public-public, public-private collaboration model. If you're in an area that's not heavily governmental or you lack some of that structure, if you will, just think tech consortium. You know, essentially, how do you get beyond some of those proprietary things so that you can share those lessons learned that are going on in preventing resiliency in your community? The steering groups, work groups, and at the end of the day, public engagement to show the success that's taken place. With that, we were very fortunate in San Antonio that we had a high concentration of cyber and intel professionals to help us in this effort, but we're really proud of where we've been in just a 3-year journey and where we're going. And with that, Chris, I'll pause for questions and time that you advise.
Sure, thank you. Thanks very much, Paul. We do have time for a couple questions if anyone has one. Go ahead, Avi.
The geothermal pilot looks particularly interesting and, of course, particularly relevant for the electric sector. I'm wondering, the geothermal project, you said you're not on the Ring of Fire, so is the idea of this pilot exploring the potential to use geothermal energy in an area that does not have the relevant strata close to the surface?
Exactly, exactly. So industry in America has definitely advanced geothermal. Geothermal's got different aspects that are unique to it. One of the things that I like about it is one of the earlier presentations talked about long-term energy storage. If you think about geothermal, geothermal is essentially a battery of its own for storing power, right? It's down in the earth, you've got that on demand, and it's ready to go. But we're not part of the traditional Ring of Fire. The Ring of Fire hugs the Gulf Coast below San Antonio, and we're right on the edge of nominal temperatures for traditional geothermal. The industry's made advancements basically on directional drilling, being able to have a design for geothermal that goes beyond just a vertical pipe, if you will, for energy exchange, but it actually provides for like a directed radiator at depth. So if you think of a crow's foot design where you go down to that heat source and you direct a radiator over that heat source, that's one of the major accomplishments that industry has brought forward. Then the coolant or the fluid that circulates in that, super CO2 has changed the temperature gradient so that it's about a 50 degrees Celsius temperature decrease required to make it economically viable now. So where traditional geothermal had a limitation that roughly 250 degrees centigrade was like the economic break-even point, these different other technological advancements have brought that temperature gradient to a lesser level. So that's really what the Air Force is trying to determine if it's viable in San Antonio. We can prove it's viable anywhere, and that's what we're going after.
So just a quick follow-up. So you're saying rather than drilling deeper and getting down to that same temperature, which you would do in principle if you could just go deeper, you're saying we flatten it out, but we make a broader radiator, and the working fluid is
close. We still go deep, but when we go deep, then we go out with this radiator effect. Essentially, you're going after a heat source as opposed to a mineral, and you want to have maximum coverage over that heat source. Sorry to cut you off, Chris.
No, you didn't. Thank you.
Sir, did I answer your question?
When you say anywhere, do you mean anywhere, or do you mean just expand it a bit beyond the Ring of Fire?
Our goal is to find out anywhere in North America. So when you think about the Department of the Air Force, the Office of Energy Assurance in the Air Force is our sponsor for this program. We've got bases all over North America, so when you start talking about critical power production, being able to island power, this is important to our safety and being able to keep those operational assets ready at any time.
Fantastic. Thank you so much. That's a really exciting final thought to end on. We'll break now for lunch for an hour. Please be back here at 1:30. And you remember where lunch was yesterday? I'm sure we'll have another delicious lunch today.
Actually, no, I just want to make sure. Actually,
Thanks, everybody. Welcome back from lunch, which was delicious. We're going to continue with the program. A couple of housekeeping announcement. We were going to do another breakout session after. We're going to actually consolidate that and just do a human continuity project session here in the room at the end of the presentations today, because we're a little behind on presentations, and that way we might be able to end a little bit early. But right now I want to welcome Yossi. Thank you for your flexibility of bumping after lunch. And Yossi's going to be talking to us about cybersecurity implications for critical infrastructures, and especially this question on AI that I think he can talk about, clear up some misconceptions, and educate us on the topic. Yossi, take it away. Thank you.
Okay, thank you. First of all, thank you for having me, and I'm glad to be here. You know, changes. Actually, I plan to open my presentation saying, okay, think about my very short presentation as an appetizer before the lunch. Okay, I'm not changing, thinking about it as a dessert. It's really some short appetizing or dessert, something talking about AI, about the which of AI, how it is connected, and hopefully it will make some, I would say, curiosity to learn and enter it more deeper, and maybe in the next conferences it will be more represented here. Let's see. Okay, so I will talk mainly about generative AI, but let me start with first question. How long has artificial intelligence, AI, been evolving? Somebody knows?
50 years.
Yeah, okay. You saw my presentation?
No, I didn't.
Come on. No, but it's okay. So actually, it's 50 years or even more, because we are counting the first appearance in 1950 when Turing was actually talking about the Turing test. Okay, that actually checks if machine is a machine, how it checks if you converse with the machine and you don't recognize this machine, it has some artificial intelligence. And then going to John McCarthy.
You like to wander.
No, I stay here.
Oh, okay.
So,
We want to hear you.
yeah. So, talking about John McCarthy, actually, is first time he used the term AI. In some presentation he gave in those years, John McCarthy is a famous mathematician, and now I will skip about 63 years, okay, because otherwise it will take me more than 15 minutes that Chris allocated to my presentation. So in those 63 years, many things happened around AI, and many things were developed. And I'm saying just that when we are talking AI, we are talking mainly about machine learning techniques. So there are different models, and I'm sure that are part of the, we are familiar with it, but different natural network models, different Bayesian theorem models, and many other models. Let's leave it like this because I don't have enough time. And I'm jumping 63 years and going to 2018 when we are starting to hear about GPT, okay, and about the OpenAI, and then in 2021 about DALL-E, the first artificial artist, or maybe not the first, but the very famous artificial, and going to GPT-3, that is additional things that we are talking about, and going now about new things like LLMs, large language models, and GPT-4 and vector databases and so on. So all those things, and please, I'm sorry if I am boring somebody, but I will take 1 minute or 1.5 minutes to talk a little bit about the basics of AI, just to understand, because otherwise I will be unclear to summarize it. So first of all, it's generative AI. Those are the things that we are talking now. Generative, it means that the AI bring us kind of something producing, really producing, not just saying AI is producing. It's actually part of the AI landscape. And if I shortly describe the AI landscape, so I'm talking about 3 classes of AI. One is unsupervised and discriminative. The second one is supervised and discriminative, and then unsupervised and generative. And I will, in 1 minute, try to explain what those different strange terms mean. So first of all, it's the classification between unsupervised and supervised. Supervised is something that the algorithms or the model are based on data that is already classified or labeled. Or if I explain it a little bit differently, the algorithm knows what is the right answer. So he is actually looking at the data, searching different things, and if he is matching something that he already knows that the label, or he knows that this is the right answer, he says, okay, this is my assumption that this is a prediction of this thing or estimation. Unsupervised means that actually I'm taking raw data and I'm creating the true or the right thing dynamically during the process of the data. So actually I don't know if the data is what is wrong and what is right, but by different algorithms and mathematics, I'm actually creating, we call it actually the truth baseline or something like this. So this is the first classification. The second classification is dealing only about the unsupervised data, and there are 2 types of machine learning. One is the discriminative, and the second one is generative. Again, very shortly, discriminative means that actually I can calculate the probability that a value of X will happen or appear if I know the Y. So if I know the answer, I can actually predict or calculate the probability that some value will appear. Generative is more sophisticated. Why? Because actually it can calculate or predict the probability of appearance of X and Y simultaneously. So I don't need some question, and I know it's a little bit confusing, so I give an example. If I, for example, take this sentence, the power shift manager activated the boiler purge procedure at 4 a.m. And I'm asking, what is the probability that the operator will do this, and is it anomalous? Is it normal or is it anomalous? So if I am working with the generative model will actually go to the data and learn and try to find the similar activity, but that happened exactly in 4 o'clock. And if it's 4 a.m. So he will find, okay, the shift manager purged, but it happened in 8 o'clock, it's for him false. So he will say probability that it will happen in 4 is 0. The generative model is taking into account the consequences and additional things, and he will look to the whole gathering of the data and seeking things that are similar or can be similar to the question, and decide if it is probable that it will happen, it is anomalous or it is normal. So again, sorry for the quick explanation. If somebody is confused, I will be happy to spend with him next 4-6 months to study all the theory. So this is the landscape. Just for example, we are not using only the generative AI. We are not using only the last wish. In cyber, we are using different things. For example, the unsupervised discriminative is used for denial of service attacks or DDoS attacks, or for example, of signature update analysis and thread allocations. The supervised and discriminative is used for IDS, for intrusion detection, for threat detection, for misconfiguration analysis, and so and so. And the unsupervised and generative is actually used for different assessment, cyber assessment, and configuration management, and many other things. So this is the landscape. So what's new? It's 55 years we are talking AI, suddenly everything. So this is new. My grandpa is a very famous, artist, you know, and she paints wonderful things. And suddenly I visited her and I see she's sitting. On the table there is a palette of colors, of paints and everything. But she's sitting in front of a computer and texting something. So what happened? So she told me so. You know, I like the smell of the paint. It inspires me to bring and create new things. So I have the paint on the table and open tubes to smell it. But in reality, I'm not painting anymore. I'm saying to DALI 3 what I think about what is it, and he paints for me. So actually, this is what happened. All new things that we are talking about, we know them for a long time, but they were democratized. They are actually today available for everyone. Every bank can use AI, can create the AI, even if you don't have any clue about computers and programming anything, and this is actually what happened. And now I go to utilities and to critical infrastructure. And what we are talking about, the cyber attack surface of what we call utility of future, UOF. Or I don't call it anymore utility of future, I call it utility of now, because maybe a few years ago it was future. Today it's not future, it's a reality. Okay? What actually happened, we had a huge increase in the attack surface. Or if I translate it differently, we have a huge increase of the abilities of attackers, of adversaries, actually to attack. So I will talk shortly about two things. First of all, smart grid. Few years ago, when I think we are talking about smart grid about 10, maybe a little bit more, 12 years, smart grid is something very nice, and actually I differentiate between two directions. One thing that I call smart grid is really taking out our grid and making it smart. For example, it will be a self-healing grid. You know, something goes wrong, the grid knows how to repair it. But going, for example, if I go to the FERC 881 order that actually is talking about the level of line regulations and different things, actually how it's done. It's done actually by implementing different systems and sensors and so in the network, so I can really bring those. But the second thing is something that I heard yesterday that somebody talked about it also. Actually, what we are trying to do for the last year, we are trying to implement in our grids new things, to digest new things, like renewables and microgrids and many other things on an infrastructure that was never planned for it. We never planned our infrastructure. You know, we planned our infrastructure according to what Edison invited and all those things. We have generation, transmission, distribution, supply. Everything is very simple. Streams in one direction, no multi-direction currents, no nothing. And suddenly we are trying to put on this infrastructure something. So this is the second thing of that. And those both things actually bring a huge amount of additional digital devices that are highly effective. Okay? So additional control components. Our new models bring additional entities involved, players like virtual power station, aggregators, prosumers, resellers, and so and so. Multi-component producer system and components. Today, we are not working with single or with few systems, and not only, a single system is actually an aggregation of many suppliers and vendors, and sometimes we even don't know really what is inside those systems. The increased serviceability and regulations that we are obliged to is actually bringing to open the borders of the data. We are actually publishing much more data that was kept once. It's something that is very confident that we are publishing it. And additional thing, maybe it's strange, but we are using for a long time, and now even more, generative and other AI in our utilities, in our functionalities, in our software, in IT and IoT. It's already there. So all those things actually enlarge the attack surface significantly. And so this is my definition. Actually, the AI, and mainly the generative AI, is actually a double-edged sword because it serves us as defenders of the network and exactly as it serves the adversary. So everything is the same. It enables fast and agile development and allows development by non-professionals. The same in the adversaries, but the target is different. We are trying to improve our security, and safety of our infrastructure, of our supply chain, and they are trying the opposite. They are trying to use it actually to so this is the situation. And you can see all those benefits and advantages are advantages of both sides, the adversaries of us. Speed of development, the ability to digest, the fast multi-source correlation, enhanced prediction abilities, and so on. Additional thing that we have to be aware is actually the double play that the adversaries play. The adversaries are using actually the AI to improve their traditional targets or traditional goals to be attacked, like our infrastructure pointing to the growing attack surface and everything. But they have now additional play. The AI components that we are implementing in our system are also new attackable elements. So, for example, there are different techniques. I put some of them like evasion and poisoning and so on. That all those things, what they are doing, they are actually corrupting, okay, the abilities of the AI. For example, I am changing the data, okay, the deep learning data that actually our AI mechanism is based on. I am injecting directly into prompts that actually ask the questions or the information from the AI. I am injecting things that are actually manipulating those prompts, and many other things. So actually, the AI, 2 minutes. The AI actually added not only additional things because of the additional digital things, but it adds additional dependence of functionality that is very fruitful, very efficient for us, but also creating additional. So just a small example that is additional thing. We like to have more and more automation because automation is actually very important, but AI brings us a new level of automation, and there are tools of automation. One of them very, very popular is mainstream tools of, it's called R2eP. I don't know if you are familiar with it. It's used even in very, I would say, operational procedure. And actually, it's open to the attacks I described just for a few moments. So, for example, a simple Freezer is a basic functionality in distribution systems. Actually, it's a functionality that enables us to fault location, isolation, and service restoration. Avi said that we must use the abbreviation, otherwise it is not serious enough. So Freezer is a good abbreviation, I think, of it. So, and what happened? Actually, when something happened and we decide, or the system, control system decides to open some circuit breaker or fuse circuit breaker or close, actually other circuit breakers are opened or closed, and we can create total chaos in our network. So this is done an example. And last thing that we have to, and I heard it many times in different explanations about silos. So generative AI mainly, because generative AI is based on what we call deep learning. It needs huge quantity and diversity of information. And if you don't get it, so I call it, it's the multivitamin of the generative AI. Okay? And if we actually don't provide it, so we are in problem, and the adversaries are gathering information, but they have no barrier between those. They integrate all this information and provide a lot of vitamins for generative AI. And we in utilities, and maybe I'm not talking about you. I know that in the U.S. everything, no politics, no internal politics, everything, everyone contributes and shares everything. But I'm talking about in Israel. We still have companies that are not only between companies not providing any information, but inside the company, the OT is not speaking with the IT, and the IT is not speaking with the finance, and so and so. So we are usually in a situation of what I call an NI vitamins deficiency or even anorexia of AI, because if we don't provide enough information about diversity, we actually don't have the proper outputs or outcomes of the diversity. So last slide, takeaways and action to be taken. Okay. So first of all, take advantage of the Gen AI. Provides a lot of abilities, but carefully. Analyze always before doing something the threat, the attack surface, and how you recover if something happens. Second thing, you will reap the benefits of AI not by cutting down the planning. You will reap it if you will have much more faster implementation and execution. But the planning should be thorough, exactly as you've done before. You can actually use AI for different planning, but you don't. It doesn't mean that you skip different steps that you have to do anyway. Remember that the adversaries have access to the same AI tools as you and from the same sources. So you have to prepare a control process of checking, testing, approving AI tools. You have to provide governance of the AI. You have to decide how you are using. It's not a free lunch that everybody can use, and you turn it actually to some attackable surface. And the richness, the last thing that I'm going to say is that the richness and diversity of data are vital for generative AI, potential benefit. So we have to change our attitude, our internal politics, our everything, and to share as much as possible the data with proper security and everything. But we have to do it, otherwise our AI will be, by definition, in lower ability than the adversary. Thank you, and enjoy your meal. I didn't correct my thing, but let's talk about dinner. Thank you very much.
I think we have time for a question or two for Yossi. Want to have one? Chuck?
One quick question, Chuck Manto from Instant Access Networks. Would AI tools be really helpful for red teaming multiple and numerous attacks on infrastructure because you can feed it multiple inputs and do red teaming from multiple perspectives?
You know, there are several tools that are focused on red team activities, if I say it, but I can say generally. Tools that are based on, for example, the models and engine behind GPT-4 are excellent tools. Because actually, if you use them and you supply the proper deep learning models and data, it actually calculates or provides you very, very efficiently kind of prediction of what can happen, much more accurate than the regular risk assessment techniques that we are using. So the probability that you get from the generative AI is much quicker and much more qualitative than the regular things that we are using. So there are, I don't know if you are familiar, there is a site that is called, I think the name is AI for everything or something like this. In 3 months, about more than 10,000 different software was born there, and some of them are very good utilities. You have to actually adopt them, okay? They are based on GPT-4 and all those new things, working with LLMs, very sophisticated LLMs, but at the end of the day, you have to choose it, and then to turn it not to something that is public, but really part of your operational strict planning. So my simple question is GPT-4, and I'm sure that there will be GPT-5 soon, and so those are the tools that we are using.
Yossi, I have a quick question. Today, most of the people here, our kids are using those platforms. I'm taking the first part of your presentation about ChatGPT and DALL-E, which I have to say that ChatGPT is the best employee I've ever had in my life. I mean, what would you recommend? How should we educate our kids, train our kids to use those platforms? Because now I had to do a project about yoga with my kid. It took us 10 minutes. Like I had everything we need in 10 minutes.
Short answer. There are two things that you have to agree with. First of all, to use efficiently ChatGPT or similar things, you have actually to practice or to know what to ask or how to ask. The constructing of your query, of your prompt is very important, because otherwise you can get different things. This is one thing.
Because we are used to work with Google, right? We know how to use Google.
There are, yeah, something like this. And the second thing is more important. You know, I am a big fan of science, of Isaac Asimov and iRobot and all those things. Big fan, but don't forget, we are still not in situation, and I don't see it will happen, that actually the center is still the human being. And what it means that actually it's true for your children, it is true for our organization also. If behind this usage of generative AI and all those nice tools is not actually kind of governance, kind of thinking. How I'm using it, it will actually turn to double sword, not only for the double-edged sword, not only for the adversary aspects, but also, you know, people, for example, are stopping thinking, are stopping to create by themselves, because they say, why to put effort? Your children, why to make homework? Why to invest in it? I asked GPT, and he puts everything. And GPT is more and more sophisticated. It produces almost everything.
Even friendly.
So this is the education you should explain, and then it can be used very, very. Thank you.
Thank you, Yossi. Excellent. We want to convene our next panel here on the electric sector data center nexus. We have Kevin Curtis, the chair, Davidson Scott, Ken Sellers, and Rick Morose. Seiler. Sorry.
Good afternoon. All right, perfect transition. Let me set the stage a little bit, thinking about data centers. So I remember working for Dominion Energy, going to see AOL data center in Northern Virginia. Who remembers AOL? You've got mail. AOL was kind of like the first, I mean, what we think of in today's terms, a data center. I mean, it was a nondescript building just over the hills from some very luscious farmland and horse pastures in Loudoun County. And it's this conflict of the very picturesque horse farm environment you might think of right out of a photograph, and then you come over the hill and there's this data center, UNet, AOL. So about 25 years ago, fast forward to now, and 75% of the world's internet traffic goes through Northern Virginia, of the world, not just the U.S. It's not uncommon for a single data center facility to be 100 to 150 megawatts. So one building that you see looks like just a nondescript warehouse is equal to 25 to 40,000 residential homes in terms of the amount of energy they use. So it's a significant step change forward. And we were hearing these very grandiose aspirations from the name brand players, the Amazons and Equinix and the Cloud HQ and all DuPont Fabros, Digital Realty Trust, all these big players, that they're going to be at this huge gigawatt number. I mean, they're talking about 1 gigawatt campuses. Some of these developers are looking at 600 and 800 acre tracts of land when they go out to plan for data center development. And I would hear this and would think, okay, I'm not sure I believe it, but I'll up what my expectations are. They far exceeded what I could even envision, and they've, in a lot of cases, exceeded those estimates. And to tie directly to our previous presentation, they said that what we've seen in growth in the last 25 years pales in comparison to what we'll see in the next 25 with AI driving additional energy use. Just for the Dominion Zone, and Ken can speak to this next, in the Dominion Zone, most of Virginia, the load is about 21, 22 gigawatts currently for peak load. That load is projected to double by 2038, 2040 timeframe. So go from 22 gigawatts to like 45 gigawatts, 45,000 megawatts in about 15 years. So picture that, and that's driving a lot of what PJM is seeing in the growth for their entire area, and it's starting to spill over into other areas outside of Northern Virginia, elsewhere in Virginia, but outside of the Dominion Zone into other areas. So Ken's got a front row seat at watching the history and the time zone and starting to see it maybe replicate in other places. So Ken, tell us what you're seeing?
Yeah, just a little bit here. So if you look at our system today, we're a 200,000 megawatt system, right? So we have 200,000 megawatts of generation. On average, our peak load's usually around 150,000 megawatts. There's a lot of changes occurring in this energy transition we're seeing right now. Between now, and I'm going to throw out a lot of numbers, so try to stay with me here, and if you have any questions, happy to answer them. But we're going to be looking at 40,000 megawatts out of the 200,000 retiring in the next 6 years, between now and 2030. So we get 40,000 megawatts going to come off the system, minimum. We're likely going to add another 20,000 megawatts of load, and that's going to be broken up into 14,000 megawatts of data centers is going to come online between now and 2030. An additional 6,000 megawatts of electric vehicle load will be coming onto the system. So net, we're talking 60,000 megawatts in a 200,000 megawatt system. In the meantime, we have this interconnection queue where we have thousands of projects queued up. We study these projects every year. We have over 250,000 megawatts in our queue that we're studying. And we'll clear that queue, meaning we'll study it in the next 2.5 years. So the expectations are, oh, we ought to be fine. In terms of generation coming onto the system, the reality of it is if you look at the average over the last 3 or 4 years in terms of generation we brought online, you're averaging between 2,000 and 4,000 megawatts a year that's coming online. So the picture is not rosy when you're looking at data center growth. And Kevin mentioned Data Center Alley outside of that Dallas airport area, all surrounding that area with all the warehouses. Because of the price of land, because of many factors in that area, now we're seeing data center growth in Columbus, Ohio, Chicago, Illinois, central Pennsylvania, right here in Philadelphia, southern parts of Virginia, down around the Richmond airport. We're seeing it start to spread across the entire footprint, even going into areas in AEP, for example, in Indiana. So our expectation is the data center growth today with co-hosting and all these other features where you may have other industries who are located within that data center, our expectation is, to Kevin's point, the load numbers are coming in faster than what we had predicted a year ago. And every year it seems like we up the load forecast adjustment because of things like artificial intelligence, which we just spoke about, machine learning. And I think those numbers that we're predicting today, 20,000 megawatts between now and 2030, are likely going to be higher. So we're looking at a resource adequacy issue as the system continues to evolve over the next 6 or 7 years. And to Kevin's point, if the growth over the last 25 years was what it was, it's likely going to be a lot higher, and that slope of the curve is going to be a lot higher in terms of load. So a lot of things moving on the system, with a lot of fossil units coming off the system, a lot of renewables trying to come onto the system. The one other thing I'll note, and I'll turn it over to one of the other speakers here in just a second, is we have 40,000 megawatts right now in our system today that have been studied. All the agreements are signed. Everything's ready to go. All renewables. Very little in terms of dollars to interconnect to the grid. So no network upgrades, just a direct connection to get you tied into the grid with a substation. Virtually zero cost to interconnect, and nobody's building. Nobody's building. So we're a little concerned. We're looking at a lot of the reasons why. Supply chain was an issue for some time with the solar panels. We have a little local opposition from the various communities, but we're also seeing a cost of capital with the interest rates being up and what they are. The projects just are not feasible at this point. So we're a little concerned around where the generation is going to come from, and we're in better shape than our neighbors, frankly. A lot of our neighbors are in pretty bad shape from a resource adequacy viewpoint. You know, usually during emergencies, we're pumping 7, 8, 10,000 megawatts to our neighbors to the west. We're pushing power to the south in the Duke, and I'm not sure we're going to have the ability to do that maybe in 5 or 6 years unless something changes. So when we think about the grid and keeping the grid up and running, we think about generation, three legs of the stool: generation, transmission, and load. We're pulling the generation lever, and we're doing a lot of things in that space. We just authorized over $6 billion in 2023 of transmission to be built. So $6 billion there, primarily looking at tie lines into that data center alley area as a result of data center growth as well as generation retirements. But the third leg we got to take a look at in a real hard way is that load. So generation, transmission, load, we're all working. The load side, I think, is something we got to take a closer look at with things like demand response.
Yeah, something that hit me in talking with some of the major data center players a couple of years ago is we've been using the term multi-sector a lot in this audience. The data center industry is a multi-sector within everything we're talking about. There's nothing we've talked about industry-wise, on any of the sectors, I don't think in here that don't touch or get touched by a data center. More cloud computing, more control, even emergency management for one state might be housed, or a function of that housed in Ashburn in Northern Virginia. It might be for somewhere else. So it really makes for a challenge. And what you don't know when you're going before the commission with a transmission line application is who's going to be in that unless they come forward initially. And some of the more, I call them highly specialized or secretive functionalities in those centers, they are rightfully not saying this is what's going to be in this data center. So I was going to, before we start taking questions, I was going to transition over to Richard and say, you know, you've been chair of a commission when the utility's bringing forth some application for something this critical, and there's really more opposition than there is non-utility support. You know, how do you manage that with the consequences of that infrastructure to society?
Yeah, thanks. And you probably thought, well, this is a guy that was on the panel yesterday talking about just regulatory issues. What's he doing sitting here talking about data centers? I actually come at this from a couple different perspectives, the first of which is exactly that, having been a chairman of a public utility commission, looking at what those critical infrastructure components are or subsectors are that need to be supported by the investments that are made in the grid. And that's the conversation we've been having here over the last 48 hours. Those are really difficult decisions, but ones that have to be at the forefront of the planning, the execution, and ultimately the decision-making by the regulators in terms of what these investments are, not just what is an investment that's necessary for today, but looking at this growth and what is needed for not only, and as I talked yesterday, not just reliability, but resilience, to look at what those potential failures are of critical infrastructure like the data centers. And that gives me the opportunity to tell you just a little bit about another perspective that I bring to a conversation like this and to some decision making, which is that apart from my position, having been the chairman of New Jersey's commission, I served for over 20 years on the board of the Federal Home Loan Bank of New York. You might not know the Federal Home Loan Bank of New York. It's a large financial institution in the region. It is the liquidity bank, the wholesale bank for largely the community banks, credit unions, and the like. There are 11 home loan banks throughout the country. Our bank in New York was $100 billion in assets and supported the banking institutions in New Jersey, New York, Puerto Rico, and the Virgin Islands. About 15 years ago, the board started talking about enterprise transformations, and about 10 years ago, the board of directors I sat on started looking at the transition to the cloud, to data centers, our data, our customer information, the banks that we serve. That is a critical piece of infrastructure in the financial services world. So from sitting there as a member of that board of directors, I was able to call upon some of the other experiences I have in the electric sector to think about the reliability, the resilience, the redundancy that's built into these kinds of centers. And those are the questions that I asked, the kinds of questions that we probed of the providers, the big data center providers. But we asked questions that went to the very substance of the kind of discussions we're having here is what kind of backup do you have for power? What is that resilience? What are those N-1-1 failures? And because it was our data, our information about the financial institutions we supported that was at risk, just as much as the fact that it was a data center that was up and running. So when I look at these kinds of things, I am able to come at this from looking at a data center as a piece of critical infrastructure, thinking about risk management, as any one of us from any one of our positions should do, whether it's Ken and PJM and having to build and maintain that infrastructure, whether it's the local distribution company, whether it's somebody who's a customer of this infrastructure, a bank who is parking its data in a facility like this, to want to know how we're going to be resilient in the management of that facility, make the kinds of investments that are necessary. And coming back to the question you asked, Ken, the difficult decisions about making sure you're making the right kind of investments to be resilient to keep this critical infrastructure up and running.
Well, I'm glad you mentioned the, criticality. I mean, obviously data centers is one of the critical infrastructure parts as defined by DHS, but what is in these data centers is getting more critical as time goes on. And if you're looking at electromagnetic threats, as you go to successive generations of processors, you're generally making your processors more vulnerable to an electromagnetic attack. So you get to a point where I know the JBSA presentation spoke that, well, we're showing that these attacks are going to be ineffective, so it's a good thing. Well, we're building unhardened data centers. That kind of goes the opposite way. So strategies for hardening data centers. Certainly if you're looking at electromagnetic attack, which is one of the more likely scenarios for a black sky, sort of a large-scale issue, you almost have to start from scratch. You almost have to start from a new data center and build it with the resilience inside of it. Now, shielding and other sort of resilience in data centers is kind of, you take a subset of an existing data center, but and the data center providers will tell you, well, we don't have a mandate to harden everything, so we're not going to do it. We're going to build it fast. We're going to build it as cost efficiently as possible. Well, that's something that's starting to change and should start to change, because if we're going to be building all these data centers as you were forecasting, it's better to start from scratch. Do things like, when you're building it, you build it with an envelope, a shielded envelope. Some of the strategies for backup power and for power need to be looked at again so that you can make appropriate adjustments so that the power is more resilient, so the data center isn't going to go down, or emergency generation, logistics, all of the things that we've been talking about here the past couple of days come into play in spades with data centers. So the hardness of data centers is a big issue that has not yet been addressed in a thorough manner, I think, and so that's one of the big issues.
Yes, I saw some hands starting to come up. Questions in the audience?
Yes, thank you. So, Ken, you gave us a lot of numbers, and they're very fascinating. If you look at the numbers that you gave for load growth in PJM, as well as the retirements, it looks like a pretty dire situation, and especially for industries that are very sensitive to any kind of power interruptions. So data centers would certainly be one industry. Another industry would be process manufacturing. So you have a factory that makes, say, automobile glass, right? If the power is interrupted to that, you can get really big losses. And I ask this question not just from a policy perspective, but even from a personal perspective. I own a company. It is a cloud computing customer. We use Azure. We also have large corporate clients that use other cloud computing providers such as AWS. If these cloud computing providers are interrupted their power, this concept that there's going to be replication, automatic failover is tenuous. I have a friend who owns a company. His AWS data was lost due to a power interruption about 3 years ago. So my question to you folks at PJM, have you modeled out, and I'll use the industry terminology, loss of load hours under these scenarios and expected unserved energy, and where will we be in 2030 if the current trajectory continues?
Yeah, great points, great question. In fact, there's a lot in that, so let me try to unwind some of that, right? So a couple things. So we have a number of initiatives going on across the entire footprint inside the organization to address this. Things like gas-electric coordination, things, making sure that the generation that we do have is going to run when we need it. There's other activities going on where we're looking at demand response programs. We're looking at our capacity market. What's our energy market doing in order to attract investment to get generation online quicker than what we have done. We're looking at other initiatives, for example, like if we have a retiring fossil unit, say it's a retiring coal plant, and say it's 1,000 megawatts, is there anything that we can do to fast-track generation, whether it's a hybrid scheme with batteries and solar panels to get that interconnected as quick as possible, because the risk of having any sort of system issue from an N-1-1 or a stability issue or short circuit is probably limited. So do we want to take the chance on first ready, first connect, to get them onto the system and get megawatts here as soon as possible? So there's a number of things we're looking at across both planning, operations, and markets, our three core business tenets that we have within the organization, and working with our states, working with our federal government, working with DOE. And honestly, we've been through a lot of transitions like this before in the past. If you look at we've been around since 1927. If you look at our history, we went through a number of transitions historically. Way back in the late 90s, we were transferring power from west to east, from the mine mouth units to the large load centers on the eastern part of our system. And all of a sudden, we had Utica gas, Marcellus shale gas, and we had pipelines all over the footprint. We had generation located much, much closer to the load. Today, we're talking about things off the coast of New Jersey, where Rich was. We're looking at 11,000 megawatts of offshore wind potentially. We're seeing 5,200 megawatts of offshore wind off the coast of Virginia. We don't have any generation to our east. We don't have any tie lines to our east. All those things are going to be critical. I think the other thing is we got to look at some resilience criteria, maybe some other things where we can lean on our neighbors. The great thing with us is we're not Texas, and I mean that in the nicest way, is we're part of this large rotating mass called the Eastern Interconnection, from the Rockies, from Colorado, the whole way to the Atlantic Ocean. We have a huge geographic diversity that we can lean on each other. So if we're in a cold winter morning and we're ramping up 10, 12, 15,000 megawatts per hour and bringing that onto the system, maybe we need more tie lines to the south where it's sunny and up here it's cloudy. So we have a lot of options, a lot of levers, but it's going to take all of those levers to be pulled across planning, operations, and markets, as well as working with state policymakers, federal policymakers, DOE, and others. I think the other thing that we're hopeful with is things like the small modular nuclear reactors, those having some sort of scalability and commercial probability at some point, maybe in the early 2030s, perhaps. So we have a lot of options. We're weighing a number of things internally. We have a couple dozen, and I don't know the exact count, different initiatives that we're working and prioritizing strategically. In fact, our whole executive team has a strategy session tomorrow to take a look at how are we going to solve some of these problems going forward. And our resource adequacy issue is one that we're keeping a very close eye on, and I think we have some options available. I'm not ready to roll any of that out publicly yet, but we have a number of options with a lot of smart people in this building that will help get us there.
So if I could just follow up a bit.
Sure.
Everything that you've said is extremely helpful, and including your public statements, and I have read some of them. In particular, your interview in the Journal of Critical Infrastructure Policy was extremely helpful to my group. Let me also say, though, we've modeled PJM. And when we talk about loss of load hours, we're talking about not dozens, but hundreds of loss of load hours, unless more generation comes online. And everything that I've heard is to put a new combined cycle gas plant in the ground is about 2 years. And so once we start growing, and by the way, load could grow in the interim, right?
Right.
And so I guess I would just say, I think that there is a place for public groups to assist in your efforts and ring the bell even louder, as Darlene was saying yesterday. But thank you for all the information.
Yeah, that's great. And I'd be happy to talk to you as soon as we're done here about some of the work that you guys have done with the loss of hours or loss of load in those certain hours.
I'd say 2 years is very optimistic.
Yeah.
Avi, and then we have another one in the back.
Yeah, I wanted to
Avi, do you want to use the mic?
Sorry. I wanted to get your thoughts collectively on the interdependency issue with the data centers. So this has come up a couple of times on the panel. From where I sit, it's looking increasingly like pretty much all of the critical sectors are now interdependent with data centers. And of course, the reverse is also true. So you have data centers, which, as you have been discussing, without power, serious issues. It's not so clear that failover is going to work in anything like an ideal fashion. To what extent is this happening? Is it a concern? Where are the industries today? Have discussions with the data center sector, the IT sector, have those begun looking at what can be done to deal with some of these concerns?
I'll start a little bit from having been in the room with some of the major data center players. When I was at Dominion and would talk about the criticality of the customers that are served by Dominion, it's all the three-letter agencies. I mean, obviously DoD, Pentagon, the major players that have influence in national and global security. And I would get comments from some of those major centers, without using names. We have some of those same customers, which emphasizes and reinforces your interdependability cross-sector analysis. I'm reassured that in talking with those folks, they are good at what they do. I mean, they're heavy-duty, hardcore, well-funded, very capable. The gaps, though, that cause me concern is assumptions that are made on what an outage is going to look like and how it's going to get restored, how long they might need to have backup generation, how vulnerable is their generation. And it's in those details that end up being more of maybe traditional utility expertise or folks like Davidson that's dealing with those resilient, hardcore, highly technical challenges is, I think, where it's not up to par. And you think about, one data center is not just for one customer. Sometimes, for AWS, it might be that building is all cloud computing. But in large part, they're co-hosting. You may have a Yahoo and a Google right beside some other critical government entity. And I think what's not appreciated in a restoration effort is it's off-site power to nuclear first. It's not restoring lights and service to the community. And then if you have a congested, concentrated area like Northern Virginia near Dulles, and it's, 10, 15, 20 gigawatts of load in that area, that's not the kind of loads you can bring up quickly in a restoration effort. You're having to build those paths gradually, and you can't just surgically go in and say, I'm going to pick up this part of this building for finance, and this part of this building for DOD, and this part of this building for some other critical function. So I think it's in those plans that you're going to actually have to use if it hits the fan is where there's some challenges. A lot of smart people thinking about it, but it's really the devil's in the details of being able to do it.
Yeah, the only thing I'd add, Avi, is, I've sat in on a number of state agency type restoration where you have an emergency drill of some sort across all the different sectors, water, gas, electric, sewer, telecom is a big one. With all the government agencies and all the coordination around how to get gasoline or diesel fuel to the backup diesel generators and that kind of thing. I think in our nation, at least here in the U.S., more of that needs to be done because I think there's a great underestimation of all the dependencies that we have out there. I've sat through at least a half a dozen drills, and I'm always amazed at learning something new every time I go through one of those. And, you have new players. I mean, I'm getting older. We're all getting older. You have a bunch of young folks coming in now who don't have that experience. They're learning this all as well. And the system's more complex. There's a lot more people who are depending upon a product that we produce, transport, and consume in an instant. We can't store it very well. So it's absolutely critical. We have more drills, more coordination across all different sectors, just not within our own sector.
But also when you're prioritizing things, knowing the priority of one element versus another and how they're interdependent and how important how do you measure the importance of an interdependency, one versus another? And so those are all issues that have not yet been confronted.
So
Last question.
just as a follow-up, as at the risk of oversimplifying, this needs to become a work in progress. And from what you're saying, it's clear we need to find a way to bring the data center industry into this conversation, right? At a level they have not been thus far.
Absolutely. Yeah, and in the back.
Yeah, hi, Ken, I was at AOL when you were there visiting, and still live in Loudoun County, and I'm very involved in local politics as a private citizen. And data centers is the top issue before the County Board of Supervisors. And I think an area that is really overlooked in terms of governance and ability to help, transmission and generation providers with the load issue is trying to help inform these boards of supervisors about especially the power implications of what they're doing. Because from the Board of Supervisors perspective, there's a tremendous amount of tax revenue coming in from this, but they look at these data centers as really a godsend because they only employ about 1/10 of the employees, and so they don't have to put in the same factor of, well, we're going to have to build schools for, for employees' children. So it seems like free money, and yet Loudoun County, which is the wealthiest county in the country, doesn't have a single person on staff, a very large staff, that has any expertise in energy, and they're desperately trying to bring something on. So I would invite all of you who have expertise and have resources to, focus on on that choke point, because I don't, the boards don't really know what they're doing. But in Loudoun County, they went from 26 million square feet of data center to 33 today. They've already approved a total of 41, and then they've grandfathered applications. It'll probably bring us to 50 million square feet. And the pressure it's putting on Dominion and PJM to try and provide that is really an unfair burden, I think, because the boards are just giving a by right, property right that then Dominion and PJM in effect have to serve. So I would just encourage anything that anybody here can do to help educate these local boards, which are approving these applications without any understanding of what the implications are.
Yeah, that was well said. I'd known you were in one of those audiences, I would have called on you in my testimony. That's exactly right.
All right, thank you very much. Show our appreciation for the panel. Thank you. We're gonna go ahead and take a breather right now. Let's just take 15 minutes. We'll be back here at 2 to 3, and we'll convene the last panel on the finance electric sector nexus, followed by a sort of working group discussion, but with everyone, since all the topics really lead into the human continuity project. We want to just have one final discussion with everyone present rather than break into the groups like we did yesterday. So a quick 15 to refresh, and we really want to start at 2 to 3, please. So see you in a minute.
Take care of my David. See David Moreau? Yeah. He's in your shop. We're in the market room. Yeah. Oh, in market? Yeah. Oh, I didn't know that. Yeah. He was in yeah. Thank you so much. Really, thank you. I'll have to check him out. Yeah. Make sure he's working. I'll do that today.
Yeah, we really appreciate it. Thank you for coming in and doing more. You're going to remind us 10 times. I don't need to. Everyone will be okay. Gavin is very responsible. I live up there. Wow.
Sharper, like
He was taking over. He decided to,
Hello? Hello?
Just had a couple of great discussions on AI, on the interaction of the electric sector and the data center nexus. Now another important interaction, the electric sector and finance sector nexus. We're pleased to be joined by our chair, Paul Williams, formerly Bank of England, now at Phoenix Resilience. Carl Kosha has joined us, risk management here at PJM, and our old friend and colleague Susan Rogers from lots of hats.
Formerly FSI.
And now from the Sumitomo Mitsui Banking Corporation. I'll turn it over to Chairman Paul. Thanks, everybody. Take it away, Paul.
Great, thanks, Chris. We're going to set a bit of context for where the finance sector is at relative to resilience, since we've been talking about resilience a lot. And then in the context of dependency on electricity, we're going to pass to Susan, who's going to give us a bit of a situation report on what the current coordination capability looks like, and then turn to Carl, who's going to give us a slightly different perspective. And that's important because
bring the microphone closer.
Resilience, is that mic? Is that better?
Yes.
Right in there. Okay. So resilience in the finance sector, there's some terms to define which I think are important. The first is to draw a distinction between financial resilience and what has become called operational resilience. So we're going to explore both of those during the discussion this afternoon. Finance sector has been on a journey globally since 2008, you'll be glad to hear, on resilience. 2008, you'll remember, was the financial crisis, and policymakers were very focused on financial resilience from 2008, which was awesome. The challenge was that between 2008 and a few years ago, and certainly to present day, the financial system as we know it has fundamentally transformed. It's become highly digitized, interconnected. Services that become offered out of convenience, consumer behavior adapts, and those services of convenience essentially become services of necessity, and then backup methods for providing those services tend to fall away. And what that means is if there's an operational disruption in the infrastructure, harm gets transmitted much more quickly and much more widely than it ever used to. Now, my background is technology infrastructure, data centers, in fact, for 25 years, and I learned a couple of things there that are relevant to where we are on resilience. One is that if you use technology as a proxy for infrastructure, people tend to care about it under only two circumstances, unless your business is infrastructure, which is that it's broken or you want to spend money on it, and those two things usually happen together. And that used to be okay 10 years ago, 15 years ago perhaps, but it's not okay today. And then secondly, if it can go wrong, it will go wrong. And that leads you into a resilience conversation. And a realization that probabilistic risk management was necessary, continues to be necessary, but it's not sufficient to deliver services to the level of resilience that we need. And that leads then to an exam question around, well, what actually is resilience then? The sharpest definition of resilience I've ever heard comes from Mark Carney, previous governor of the Bank of England, who said it's the ability to absorb shocks, not contribute to them. And that defines so many capabilities that you need to have to continue operations in the event of inevitable disruption. And then if that's the case, when we set out to design regulatory policy for financial services in the UK, there were two questions that we had at the top of our mind, and I think there's still the two questions from a resilience point of view that firms need to be asking themselves. We, as a regulator, wanted to be sure that the things that we cared most about were delivered to the levels that we expect. And that opens up two enormously complicated questions, which is, well, what actually do you care most about? The point yesterday around protecting diamonds like diamonds and pencils like pencils, that talks exactly to that point. It's a remarkably controversial question, it turns out. And then what do you expect is potentially even more important in a context of inevitable disruption, because what you then have to do is to define how much harm you can absorb, you can tolerate before that harm becomes intolerable, either to yourself, to your customers, or to the system in which you operate. The so what of all of that is that finance is on a journey to better understand its critical assets and the services that they deliver in a way that it's never really understood in the past. But finance doesn't exist without energy and, in fact, telecommunications, and that's therefore where we get to the panel discussion around, well, what does that look like? If finance can be sharper in its service needs now than it ever has been, what does that mean for resilience discussions between energy sector and perhaps telecommunications sector? And the dimension for those conversations, of course, is both pre-shock, pre-crisis. Resilience capabilities are built before the shock happens. They're a community affair, so what does that look like and how do you build those? But then how do you coordinate during a shock and prioritise? We've heard a lot about prioritisation of service restoration. You're dealing with a highly digitized, interconnected financial services sector that's beginning to understand where its physical footprints might be. But the previous conversation on data centers and cloud in particular makes it harder to actually know where firms' physical infrastructures may be. And in fact, if they're using cloud services properly, it might not matter in the way that it did if they're using multi-region to drive their services. So we're going to explore that in a bit more detail. The US sector is in a very different place from the UK sector, I've observed from previous discussions. So Susan, perhaps you could tell us where the US finance sector is at. I've heard something referred to as the tri-sector playbook, which sounds intriguing, but perhaps you could expand on that.
Sure. So let me give you a little background. So I started, when I was with GMAC, 1997, I was given the Y2K project, okay? So that was the start. And it's really funny. If anyone, show of hands, anyone do Y2K? Ah, there you go. There's always some of us. So, but we had all the foundation, right? What's critical to facilities, people, process, third parties, right? Which is really the foundation of resilience. So I was also, even though I worked in technology, I was always part of incident response. So in terms of how we responded to 9/11, right? They used our continuity plans. Also the 2003 blackout, right? Which many folks, Northeast blackout, many folks were aware of that. But what I've worked, before going to Sumitomo, I worked at FS-ISAC. So people familiar with the financial services ISAC. Now my role was during the hurricanes, right, to jump on to support FEMA's effort, to support the U.S. Treasury coordination that takes place, ensure cash gets where it needs to be, and all the history that you learn from, I was there 7 years, so all of these critical coordination points, which are so applicable to the things that I'm hearing today. So here's what we do, okay? First of all, there is a National Council of ISACs, okay, which is cross-sector in nature. Now, the U.S. side, you have the National Infrastructure Protection Plan. It defines how coordinating councils will work together. I think there's 16 original. And from that, the coordinating councils are policy, the ISACs are the operational arms. So a lot of folks think of, I mean, I do cyber resilience now, and a lot of people think of ISACs as cyber, but that's not how they were originated. They originated for all critical infrastructure resilience. So reporting, coordinating, physical response, physical disruption, as well as cyber. So the first thing, we have the infrastructure in place. It's all about coordination. Our financial sectors are the institutions connected to the ISACs. We also are connected through trade organizations. So the example I can give you too is, as an event unfolds, how does the industry come together? On 9/11, the U.S. Treasury has a story that when 9/11 occurred, the coordination was not there. And they say the day after 9/11 occurred, probably a month after, they created a structure called Chicago First. And that was one of the first public-private coordinating centers. And from Chicago First, they built the standards. From a local level, how do these first coalitions engage? So from a standpoint of now, part of this is, when I think of incident response from a financial sector, we have industry partnership roles. People within our companies have that responsibility. They look at this from a planning standpoint, from an actual event, and then from a response and recovery. They follow, when you look at the regulators we have, right, the Fed Reserve, we even follow Bank of England, okay, if we're global. So the idea of following the NIST cybersecurity framework, which also covers, you know, if you're ready for cyber, you're ready for critical infrastructure disruption. So there's more to it. I don't know how much you want me to go into it, how deep.
That's fine for now. We'll come back to it, I think, in further discussions. Carl, perhaps we can explore a slightly different perspective. Could you talk a little bit about your experiences in Germany relative to Russia, Ukraine? Because I think that talks to a different side of coordination.
Yeah, you know, I don't think I fully put two and two together who I was sitting up here with until you guys introduced yourself and spoke. So, you know, look, just following Susan, I think my job and probably the job of a lot of guys who sit in seats like me throughout the industry are, we want to make Susan's job easy. You know, our whole goal is to keep the lights on so that we don't need your planning. And when I think about Paul's job, you know, Paul is you are the regulator for one of our primary markets, which is ICE Clear Europe in the Bank of England. And so, you know, again, we're all pretty much intertwined. And, you know, I think about this stuff and what Susan said and what we heard earlier, you know, maybe this doesn't resonate with you, you're not being maybe an American college basketball fan, but, you know, Coach Wooden long ago said, failing to prepare is preparing to fail. And that really does kind of set up how you make yourself resilient. You prepare, right? Now, I don't know that anyone, I went to Europe because they told me I could enjoy a European lifestyle. And I didn't have to work for a global commodity merchant and be on the road 120 days internationally a year, be away from my family 4 days a week. And then on my wife's birthday, Putin invaded the Ukraine, and 80% of the German gas supply basically dwindled to 10% of its aggregate supply. Half of our coal supply evaporated. Our nuclear plants were all scheduled to go out in the very next year. The French nuclear plants weren't quite on D-rate yet, but they were getting ready to go on D-rate as the hot summer came. And oh yeah, then there's this little thing called the Rhine, which for Americans we think of as the mighty river of Europe, which it is. It is a mighty river of Europe, but it is not the Mississippi, and it is not controlled like the Mississippi is. So this thing goes up and it goes down, and at its worst, it was a meter wide. Well, you can't move coal on a meter wide river. So how do you deal with that? Why does it affect your financial sector? It does it because when your primary gas supplier goes out, you look for other gas suppliers. When your primary coal supplier goes out, you look for other coal suppliers. When the world doesn't have that sector, what happens to prices? They go nuts, right? You know, we saw $1,000 prices trading in Europe. I think even the American press picked it up. We saw natural gas prices, you know, of what, $360 a megawatt hour, which is somewhere around $70 an MMBTU, and that was, you know, that was for prompt. We saw summer trading well above winter, even though we knew where winter was. And at one point in time, we posted $6 billion over the course of 3 days to cover our hedges. So how does it all work? How do you make yourself resilient? You know, when I got there, we didn't have a model for if prices, we weren't modeling what happened to our working capital. If prices went to X, if prices went to Y, we weren't modeling where do we get our fuel supply when it's cut off. And we had to quickly build this stuff. Now, luckily, coming from a global merchant, one of the first things I looked at was how do we model our working capital? How do we model what our requirements are going to be for our exchange? Are we pricing our deals even appropriately so that we get return on it? Or are we kind of mismanaging our balance sheet? Because it doesn't really matter what kind of company you are. Like I used to ask this almost as an interview question, what is a trading company? And the answer that I hoped for and I expected was, it's a collection of people, assets, and a balance sheet. But really, that's every company. It's a collection of people, assets, and a balance sheet. And that last one is probably the most overlooked one because we never really think about it until you have to. And then it's just a touch too late. It's just a touch too late to be thinking about that. So, like, the thing that, like, I want to impart to you at all times when you go back to your company is the way to absorb those shocks, the way to prepare yourself to absorb those shocks is to understand how stress comes into your body, how stress comes into your corporate body. You know, and think about like a boxer, right? What do they train? You know, there's the old adage, kill the body and the head will die, right? So they train that body to take those shocks. In your corporate body, you have to protect that asset, which is primarily your working capital. And so you have to know, like, how do I absorb this stuff? How does it all work for me? How does it flow into my balance sheet? And what are my kind of liquidation strategies or management strategies to protect myself from these shocks? So, you know, I'm happy to answer a variety of questions to the extent that they're not proprietary. But I don't know that you can face a larger resiliency test than exactly losing your fuel supply for the way you generate electricity. And we would have regular meetings around how would we shed load, how do we optimize our coal burn, what are our gas plants that we can dispatch because they do or do not have fuel, and how much could we move in and out of England? Oh, and by the way, like the little secret Europe doesn't tell you when you're an American is that it's all connected, but the French dye their gas and the Germans odify their gas. So the two gases cannot move even though they're the same gas. So there's all sorts of little things that, like, when you think you're prepared, you might not be. And I guess that's really kind of where I want to start this.
Okay, thanks, Carl. So it raises a kind of the question I've never really been able to get my head around. It's all well and good having an ISAC which can coordinate in a crisis, but so much of the infrastructure that supports the financial system and indeed the speed and the volatility of markets is so rapid that waiting until that crisis happens to work out where your dependencies are, if you suddenly get a request to load shed to the finance sector, how do you even begin to understand that? Is there a role in the ISACs pre-crisis to think about dependency mapping and management such that you've got in these playbooks and preconditioned responses to things like load shedding?
Well, I don't know if we've gotten to the level of load shedding, okay? But so one thing I didn't mention earlier was this concept of a tri-sector playbook, okay? So as part of the ISAC, the finance ISAC, electricity ISAC, and also the telecom coordinating council, we got together, we created the young woman who was here earlier, Bethany Netzel also was an author on this. So the idea for this was, as you're in the heat of the moment. So I'll answer your moment. I'll answer it in a second. But I just wanted to make sure that that's known because the sector is really getting used to coordinating, getting quickly. We have playbooks that we coordinate. The other thing to remember is as an individual entity that joins an ISAC, you have the ability to request information. So you can go to your ISAC and say, I need to know this. Can you find it out from the government? Can you find it out from another CERT in another country? So that's the sense also, is that it's a situational awareness during an incident. But your question was, okay, so this is where I actually met Paul, was around operational resilience. Do we understand what is most vital and critical to finance industry? So a couple things. Around the same time that we were looking at OPS-RES, CISA was also defining the critical national functions. All right, if you're familiar, you Google critical national functions set, right? And it's all the critical infrastructures, right? And what's most critical, that there's 6 of those functions are finance. And it's interesting because they do parallel. When we were asked by our regulators to determine most important business services, they parallel that critical function. Now, when we were building that CISA model, we were also meeting to say, what are the independencies? So there are plans out there, right? And that's another thing is there's been a lot of thought and analysis by U.S. Treasury, by Department of Energy, to think about, you know, if that infrastructure fails, how does it fail? What are the independencies? Now, in the finance, there's also, this really was activated during the pandemic. There's an institution called Core Executive Response Group. And that activates whenever there is a sector disruption or the threat of a sector disruption. So you have regulators getting on the calls, you have critical financial institutions, the utilities, DTCC, CME group. And right there, it's what do we need? How do we coordinate? It's a very TLP-read confidential level. So that's another thing. A lot of this, in order to do this planning, it's confidential. It's how do we safeguard what we're actually defining and building. So I think I wanted to make that point, that there is a lot of collaboration, there's a lot of coordination. But then you go through on an individual level, right? Each institution, let me give you an example. In the finance industry, we've had some really significant cyber attacks that physically disrupted the financial markets. One was ION, was the event. Most recently, the event's called ICBC, which is the largest bank in China. Their local branch in New York was attacked by ransomware, and it caused ripple in liquidity. So one of the things finance industry is doing right now is really thinking through, when we respond from a cyber incident, are our critical business leaders connected to that? So what happened through these cyber events is it actually drove what Bank of England, is this idea of what do you really understand what's critical and operational, and then how do you actually put it together? So it's not perfect, right? A lot of it is, do I understand who, what, when, where, how, right? That's the idea of playbook development, of concept. When an event unfolds, how do I prepare enough so that we can collaborate? So you have playbooks that are, and this is a lot of the sectors doing this. You have sub-playbooks on ransomware being built out. You have sub-playbooks on cyber impacting liquidity. So all this idea of how do we think through, how do we build the muscle memory, it's all about exercising, okay? And then the frequency with which you're exercising, that's another thing we're doing.
So can I introduce a question? The following occurs to me, and it's really a question. A lot of the capability that has been talked about in the approaches relate to fairly conventional hazards. Really the focus at this conference and what we've been talking about is black sky events. And a black sky event, let's look at a very severe black sky case. The Eastern Interconnect is down, which once it goes down, it means you're talking about, I don't know, maybe a month for it to come back up. In that environment, communication, depending on what's been put in place, will be extremely limited. And yet, I would assume, welcome your thoughts, some level of finance is going to be critical in order to bring things back up, assuring providers, generators that funding will come. It seems to me that this is a very fertile area for resilience development, which has not yet been done, I would assume, but I welcome your thoughts.
I mean, I actually think, in listening to this, that's actually exactly where I was going. And if I think about the rules that we operate under, we operate under a very strict tariff, and that, unfortunately for almost all of us, right, where we are today is a product of where we've been in our past. And because PJM has had some issues around credit in the past, we have very strict rules around credit. And I can imagine if there were such a black sky event, our rules around credit would basically require that we remain connected to the financial system and or go and seek a waiver, an emergency waiver from someone, FERC, I guess, maybe DOE, to effectively operate in lieu of those rules. And that's a really odd concept to think about, but I think it's probably worth thinking about. Like, how would you do it? Because, you know, look, it's a really delicate sword, right? We try not to create burdensome costs for our members to remain over-collateralized. Banks face this issue all the time, right? What is the capital you have to hold against your obligations? So we try not to create these burdensome rules that around over-capitalization. But on the other hand, what that implies is that when things really go wrong, there's not a lot of free play in the system. The system relies on itself continuing to work. And so, really, while my job is to make Susan's job easy, in the event Susan's job is required, it enables us to restore ourselves in a normal course manner. And, you know, I'm not sure I had put that puzzle piece together in my head until right now. I'm sure I would have in the moment, but it's painfully obvious now.
Yeah, it's a learning, certainly in the finance sector, if we go introspective for a moment, that comes out of cyber work, and Susan and I were talking about this earlier. We've run, I'm ex-Bank of England, by the way, I'm not presently with the Bank of England. When I was with the Bank of England, we ran a G7 cyber exercise, and one of the key learnings from that is that when a cyber event happens, it's a very technical thing that's happened. What's the nature of the malware? What's it disrupted? How long is it going to be disrupted for? What do you need to do to get it back? And whilst the technical folk, the cybernauts, are running around with their hair on fire trying to answer that question, business consequences are occurring somewhere, which I think is the root of the problem here. And I don't think it's something that's been explored. I think there are... and I'll turn to you, Susan, in a moment for your view, but I think exercising is a key part of this. There are two routes that I think will answer this. One of the key things that financial services are required to do is to some extent try and insulate themselves from these severe events by understanding how their services are delivered and then assessing their ability to survive those events against a library of what we call severe but plausible scenarios, very specific language that gets them beyond the probability to focus on these rather existential threats. I think the question posed touches on an area that should be part of the severe but plausible library, but I had a question for Susan as to whether you think prolonged wide area power outages are part of the scenario library. In the UK, I think it's starting to come, mainly because that concept is actually on the UK government's National Risk Register, so that informs some level of facilitation of that. So two questions for you, Susan, I guess. One is, do you think US firms in their severe but plausible library have black sky, prolonged wide area power outage events in the severe but plausible library? And two, exercising seems to be the area where you'd explore this, and perhaps EarthX at some point is an ideal platform to explore some of these issues.
Yeah. I'm not sure about the first part of that. The severe but plausible, let me answer in a different way. I think the timing is really interesting right now, because what the finance industry has learned over the last 6 months with these types of ransomware events, a couple things that, first of all, they'll have manual processes they're putting in place. But part of what we have to do is ask them, well, how long does that manual process, can it sustain itself? And that's where you've got the issue of longer-term outage, right? Because in many cases, the answer is 24 hours, 48 hours, right, before there is intolerable harm. So that's part of this idea of, you know, teasing that out, and can we present this? I think it's good timing to do this. So I think that idea, let me mention one more thing that we're also learning from ransomware. When you get disconnected, when you have the interconnectedness, right, of the finance system, right, you have SWIFT systems, you have ICBC. I mean, the reason why these were events is they were used by many companies, and you had to disconnect from those systems because it was infected, right? You're afraid of cyber infection malware. How do you reconnect? How quickly can you reconnect? How do you know a system is clean? So that reconnection process and the ability to assure your customers or interdependent companies and institutions, it's really a challenge right now. So that's going to extend it. Is it going to take 2-3 weeks to have CrowdStrike look at that infected system, go through and give assurance that, yes, the following was done, you can reconnect? So these are things the financial industry is really waking up to. And I think, Ari, I think what I've heard and learned is it's a good opportunity to put this into our exercising.
Yeah.
I know that Carl has a hard stop here in a minute. I just wanted to ask, your introductory story about the interruption, invasion, the interruption of gas and coal, and how that then translated into kind of havoc in the financial side of the energy business. Do you see that as bidirectional? If there's an attack just on, the functioning of the capital markets that value or allow buying and selling and trading, would that lead to, could you see real interruptions in fuel supplies by attacking the financial markets rather than a gas pipeline?
For sure. I mean, if you think about, because we weren't super adequately prepared for this, and we weren't, let me just give you a really basic example. Like, we sized our lending agreements based on the size of, what an LNG cargo would cost, at the time, which seemed prudent, a set number of cargoes. But when those cargoes, are worth 5 times as much, if you thought you could move 6 cargoes, you can now move 1 cargo at a time. When you've got a lay window into South Hook in the UK and you need to deliver your LNG ship and you've got to have your financial institution, you've got to move money super fast so that you can free your LC, so you can post your LC, so you can hit your laycan window, so you can deliver that gas, move it through a pipeline, and get it into the EU system. So an attack on the financial sector does imperil the physical system because of the interconnected nature in which we deliver that fuel, right? Whether it's by boat, and we forget, we think everything moves at the speed of light, but maritime law still moves like maritime law. The rail system still moves like a rail system. Delivered in place means that's where it is. And so, again, let's go back to, we're all here from the journey that got us here, right, in our history, and all these systems have not quite moved up into the same spot. And, a lot of people are talking about how to move things faster, but it all still remains connected.
I could add something to this. So there are some trade groups in financial industry that are interesting to this. So one is the SIFMA organization. So this is in New York. They coordinate the security, sustain safety of the workings of the financial markets, okay? So when there's a disruption, they activated during Hurricane Sandy, during 9/11, right? And they'll close down. I mean, there's safeguards built in, right? That if the market has to close down, if there has to pull a trigger to slow down trading. But what's interesting is there's a futures industry, okay? Futures industry is around the financial side of commodities, okay? They have actually, Chicago Mercantile Exchange, right? Chicago is the commodities market. So those folks are also part of this. I think it would be interesting to explore that, like how the implication in the supply chain, all of that those entities should have more insight into that, or if they do, what it would be.
I think what we're learning from those discussions is that the electric finance sector nexus is a multi-dimensional place, a multi-domained environment, and there are at least 4 domains. One, as I set out in the introduction, has become clear from this discussion. There's financial resilience and operational resilience, and they are connected. Financial crisis can lead to an operational crisis and vice versa. And that secondly, finance and energy it's a bi-directional relationship. We're customers of each other, and there's a dependency mapping there. And then lastly, the point that I'm still unconvinced on, and it's where my mind goes to, maybe it's a bias I have, is when we're talking about coordination, it goes to a very physical level. And I'm still not convinced that any level of dependency mapping and management between finance and energy is a fool's errand, because you simply can't do it in a meaningful way. Particularly if you take financial services firms are enthusiastic users of cloud environments, and it's a very specific type of data center usage. But the conversation previously around North Virginia, Amazon Web Services has 6 availability zones in North Virginia, and North Virginia is one of 8 regions in the U.S. And each availability zone can have more than one data center within it. So there could be many, many data centers that constitute an availability zone. If financial services firms have done their job properly and understood the criticality of their services, they will have distributed their services across regions. So they could switch from East Coast to West Coast in a heartbeat if they're using their cloud environments correctly. And trying to map the data centers that those firms might be using is actually impossible, because even Amazon doesn't know which data center the data is in. And the people who look after the physical assets for reasons of security actually are prohibited from knowing what's actually going on inside those data centers. And that leads you to conclude that trying to map in a meaningful way what the dependencies are such that you can restore in a critical way, it just seems impossible to me.
There's something going on, though, that might help with this. So these are papers you could pull out on the internet. So one is the U.S. Treasury Cloud White Paper. It came out about a year and a half ago, where they looked at instead of saying to financial industry, don't go to cloud, you can't put critical on the cloud, well, they realized you can't stop the water flowing, right? So they talked about the benefit of the cloud, but then they said, we've got some big issues we've got to solve. So from that was a series of working groups that were created. 3 of those working groups are run by the regulators, 3 are by private sector, and 2 are together. You know, I wonder if another working group should be created. Because look at what was mentioned about the data centers, right, the growth of that. I think there's something here. I can't share all of the activities that they have, but they're trying to solve some big problems, right? Like Treasury is saying there needs to be increased resiliency built into these cloud contracts. And it shouldn't, and you know what? How come there's certain implications when you install cloud that they should be more resilient in their instructions so that you're making it, so these are different things that, what about questions about data center, about hardening? All those things could be a part of it.
Okay, very good. How are we doing for time, Chris?
I think Carl has to go.
Yeah, I can be a couple minutes late if anyone's got anything in particular for me. I'll answer it quick.
I see your question.
So, excuse me, this has been exceedingly insightful. So Pittsburgh has BNY Mellon, PNC. I came from Columbus, where Huntington Bank was. First off, this conversation has enlightened to some degree when they come to us and like, hey, we want to talk about these things in these very ghost-like back rooms. So that opens that door. The second is, from the power provider, from just transmission distribution, we're just wires business and substations. What conversations would benefit our banking partners in downtown Pittsburgh and our golden triangle, if you will, so we call it? How do we present to them? How do I go back? Like, hey, I listened to this amazing panel. These are the things I now want to help create additional resilience on the layers we have. So like, what are the takeaways I need to go back to my banking partners with outside of the amazing half hour you just presented?
Good question. Susan, do you want to answer that, or do you want to go?
Sure. I love Pittsburgh, by the way. I grew up in Philly, so we have this competition between Steelers and Eagles, but we'll just forget that. Right? So, it's interesting, is from an electric sector, it's interesting you're saying this, right? So things like, first of all, have they mapped their critical data centers? Do they understand their critical assets? Have they asked you to, there should be a priority of recovery for critical facilities. Have they told you about where those critical facilities are? I think that's just a start, but it's, are they part of critical infrastructure recovery? Are they part of their ISAC? Do they have, some institutions themselves have fusion centers, right? Can they connect you to their fusion center? Can they connect you to their crisis coordination group? So the more that they can connect you during a crisis, the better you can help them. Yeah. That's it.
Yeah, I probably got to take. Well, look, thanks for having me. Or Mike, did you have a question? No. Okay. All right. Thanks for having me.
Great.
Okay, thank you.
All right, thank you very much. We're going to stay in the room here. The working group is going to be one large working group, but let's all just stand up for a second.
Good idea, Chris.
Wake up. We want to be interactive on this last 20, 30 minutes that we're here.
I'm one of those guys. I always find yeah, that's right.
Right now, I thought we would in the final discussion of the day, sort of a large working group here on advancing the Human Continuity Project.
Okay. Can you hear me in the back?
Guys? Tom? Tom?
Is this better? Closer, better?
Yeah. Yes, it's working.
All right. There we go. Speak louder is the answer. Look, this has been really outstanding, and the outstandingness comes, I think, from a combination of superb panelists and an amazing group of delegates, audience, all of you guys. So this has been a collaborative conversation, so thank you so much. I wanted to do two things. I wanted to try to do a wrap-up, hitting the highlights of what went on. I gave up on that. It was too successful. There have been far too many fantastic developments, new opportunities to summarize effectively. I'll say just a few things. But what I'm really excited about is follow-up. And follow-up has two meanings in this context. One is these post-conference working groups. I think probably everyone or nearly everyone has signed up for some of those. If you haven't, see Leahy and sign up for one of them.
Email both of us. Tell us. Remind us which working group you want to follow up with. We did get some notes yesterday, but just to make sure, but please shoot us an email and we'll connect you with the discussion leaders.
Or heck, if you can't figure that out, we can invent a new one. Okay, the other follow-up is the Human Continuity Project. And for that, again, you can talk to Leahy, we'll get connected, we'll make sure you get materials. Most of the people here, I think, and the corporations that stand behind you would be extremely relevant and helpful in moving the Human Continuity Project forward. So I'll say a few things in summary, and then I want to make some wrap-up comments and basically solicit your questions on the Human Continuity Project. So we went through a number of panels that touched in a few different areas. We started out by talking about black sky threats. That's easy to summarize. They're horrible, and they're getting worse. You know, there's malicious, they're natural. You know, my biggest fear and terror right now is for the malicious threats because they seem to be growing very rapidly, but that's just because we have no idea when the natural threats are going to hit us. We talked about black sky redundancy. Wanda Reed, are you still here? I think Wanda had to leave. That is a crucial subject, and that became clear in the discussion. There are big issues. We've seen multiple times in discussions over the last few days what was successful in Ukraine, and it has to do with human and hardware redundancy, which at this point there is not a financial framework to pay for in the United States. Is that a fair summary of the conclusion? That's something that we need to think about, and thinking about it and doing something about it comes down to policy. If we're going to affect policy at that level, it's going to take a very wide tent. And that means, for example, the Human Continuity Project. Another subject, Black Sky, Black Start, Paul Stockton led that discussion. This is an area that includes technical recommendations on what needs to happen, but fundamentally most of those technical recommendations come down to policy. How can we begin influencing policy? It's going to take a very wide tent. The Human Continuity Project seems like an excellent way to get an extremely wide tent to start influencing policy once again. We had a policy panel, same answer. The energy sector web. So this is an area that I found particularly exciting. It seems that there is broad interest in seeing what can be done to build on this, and potentially it could be a seed to build an emergency communication system out that could gradually move across the United States and then evolve. So that was particularly exciting. There's been a lot of progress talked about at this meeting. I would say most of the areas that we talked about, what needs to be done, where do we need to go, will require very high-level, significant new conversations in policy. And in order to influence policy, it's going to take a very wide group of corporations across many sectors to be singing with the same voice and the same tune to decision makers in the United States at the state and the federal level, in partner nations, depending on what their structure is. So the Human Continuity Project is meant to do that. There has been a lot of progress in particular locations, particularly on the eastern side of the United States, with all thanks due to PJM and some of the key member companies, but also water companies, some of the other sectors. There's been progress in the United Kingdom, I think, especially in the finance sector. I think Paul Williams, who just led the last panel, a lot of that is attributable to you, but obviously an enormous amount still remains to be done. And of course, in Israel, there has been progress, EMP protection, emergency communication perhaps on the way. So there's a lot to come, but these represent relatively small successes relative to what is needed. And the answer to turning small into big is to try to create a platform that can be far broader than anything we've seen before. That seems to be coming into place. And the Human Continuity Project is meant to be a very systematic process that can provide the kind of framework that will be needed to make serious progress. As I summarized very briefly this morning, that framework is the systems engineering process that has been very successful in the aerospace industry at taking interconnected systems, finding ways to weld them together that will be resilient and will be successful in avoiding single point failures and at the same time make room for the kind of very high quality, high level modeling that can provide decision support. So that's in a very small nutshell the plan. What I wanted to do with the remainder of the time, which is what? If we want to stop at 4, Chris, 10 minutes? Okay, so 10 minutes. What are your thoughts? Does this make sense? Do you think your company, the company that stands behind you, might be interested? What would it take to interest them? Questions?
I think one of the big things that we always hear, benchmarking, I swear, benchmarking is tattooed on our executives. Someone like in a trade, so like EEI is a trade association endorsing this, and if you want to call it benchmarking, it would quite literally be like a Dominion, the Duke, the AEPs, EEI, not benchmarking it for everybody, but endorsing it with as like the I'll say industry leaders that people look to. It's like, well, we're going to benchmark. What is Dominion doing? And that's a common phrase we hear. What is PPL doing? They're the same size of us. So I think that would be, if you want the executive buy-in from like EEI members, like that would probably be the first executive question is, what is everybody else doing?
Okay, well, for EEI, I'll go beat on Scott Aronson. He's expecting me to go hammer on him soon. But beyond that, I think we already have made excellent progress, right? We do have NERC, and of course, Manny at the EISAC.
You can hammer us too.
I'm sorry?
Said you can hammer us too.
Oh, okay, but that's okay. They're already planning to participate in the Human Continuity Project.
Avi, can I cut in though, just to, Adam, just to ask you to just refine that a little bit. Are you saying not just encouragement from, say, EEI or the EISAC, but for them to actually provide to other members, other EEI members, some examples of say, what Dominion and Exelon and PJM are doing that then other EEI members will be able to kind of follow suit?
Yeah, so why are you taking me away from capital projects? Why is this more important than a capital project where my investors are making money?
Okay.
Just also add, I mean, I think that's a great point. But it's not just, and I'm not advocating any responsibility, we do want to push this along at NERC. But it is finding a way, and I don't know that I have the answer for this, but to get to the sector leadership and educate them, right? You know, so the ESCC is a convening body, right? You know, how do we share, you know, and again, I mentioned the GridX After Action report where probably more specifically on the communications opportunities, we can talk about some of these things, right? But I do think that you eventually have to bring them into that tent that you spoke about to sort of get some traction on this and move this forward. I think the other thing, and I have this conversation with Scott and the other trade association heads all the time, is we seem to go from shiny toy to shiny toy to shiny toy, and then we go back around and we get back on it, right? Depending on what the current crisis is or the flavor of the day is. But if we're going to be serious about, you know, taking a chunk out of this and making some progress, what's that flight plan look like, right? So, for example, Scott put together a proposal for how you might build out, you know, BNet. Good, bad, or indifferent, but I think people, without seeing that flight plan, or at least a high-level structure, it's hard to sort of, you know, sort of visualize what that future would be like.
So that sounds absolutely right to me. And in regard to the flight plan, we've got one. I think it's pretty good for a start. Anyone who is interested, please get in touch with any of us at EIS Council. We will get you the very latest versions of the project plan, the backgrounder that includes the current membership list. And Adam, it does include a pretty good list of some of the big power companies and associations. I believe there are some more that are about to join. So, yeah, Craig.
Hi, Avi, and thanks for all for doing this. You mentioned policy about 3 or 4 times in that summary, and influencing policy, frankly, requires, or something I do deal with, requires the expenditure of political capital. And, you know, this industry has a great tendency to just talk to itself and not talk to others out there. Or if we do talk to others out there, policymakers, sometimes it's with very disparate messages. So I think it's important to really, A, get the support and people's willingness to expend some political capital on these issues, and B, get the message beyond just talking to ourselves, but also really, and you've done some of this, really get out there. All politics are local, so that's important, and get out there to the policymakers and let them understand what this means for them and for their constituents.
Yeah, no, I agree. And I think the fact that your company, the company that's hosting us here today, PJM, has already signed up to participate in this means that there is a certain willingness to expend political capital, but the amount of political capital that will need to be expended is not nearly as large as it would be if this objective were not meant to be a multi-sector objective. Because if we deal with some of the largest companies in many sectors, and we all collectively are going forward with similar recommendations, hey, we are collectively heading toward a brick wall, we think that's bad, here's what we see as critical needs, then I think that in itself can help move the ball forward. Yes, please. Microphone.
I was really struck by your story about FEMA as you were introducing the Human Continuity Project. And it actually reminds me, like, the need statement now about how to almost institutionalize it and socialize this concept across government and industry, I guess, in society at large. It reminds me of something else. Maybe, okay, there's, I think, one avenue to start reaching a wider audience and gaining traction that could translate into decision process and access to funding. Sounds kind of hopeful and superficial, but I'll tell you why I think it could work, is to seek presidential executive order on this topic. And I say this because I'm aware of, I can't remember the number of the executive order, but there's one that says all federal agencies for any decision over $10 million have to go through a value engineering exercise to essentially kick the tires, and usually they just kind of dumb things down and shave off some bucks from a budget, but they're supposed to improve the performance in the process of doing it and really reconsider how to scope and address something. The flip side of that would be looking at the failure mechanisms and the effects and the criticality of so many of the systems that, as the Human Continuity Project is all about, highlights how fragile and interconnected many of our systems are and how poorly anyone understands how they work and how badly they can fail. So by institutionalizing a need to assess that would be interesting. Now, the VE executive order for value engineering is based on the premise that it never doesn't make sense from a financial proposition to go through that process. Case studies have substantiated that it always is the right idea. It saves money. In the case of FEMA at the social value level, you're talking about saving a lot more than money.
Yeah, and incidentally, it's FMEA, just so you'll get it right when you Google it, so you'll be able to find it. But look, the fundamental layer within the Human Continuity Project is going to be the corporate world, with a heavy participation of infrastructure corporations, but it's going to take more than that. It's also going to take some of the really big internationals, but all of the big multinationals now also have become infrastructure companies. Having political top cover, like with an executive order, may be helpful. What the process would look like and at what point in the development of this project that would become credible is a question. But, you know, let's follow up and continue the conversation. Any other questions?
Over here.
Yes.
So, I think when I look from a financial sector, right, the risks that's been talked about here from data center growth, the lack of hardening around that, industry's already concerned about AI risk and even quantum computing. So, and they're realizing this issue of longer-term recovery. So, I mean, actually, Paul and I, we've talked about a couple ideas around how to present this to the physics coordinating group. So I think that would be a good step. And Paul would kind of be driving this.
That's the which coordinating group again? The FSSC. See, right. I have to stutter correctly in order to say it. Yeah. Okay.
Those three things would be enough: the data center, the AI, and then how they're looking at quantum. I mean, I really think you can get them to want to play out an exercise, get them to look at standards, get them to look at the.
Hey, Avi, can the audience use the mics?
It was on, I'm sorry. I said Human Continuity Project.
Yeah, well, let me paraphrase. I think what Susan just suggested is the FSSCC. Yeah, I think I got it. In the finance sector could help significantly to move this forward, especially if it were made clear that key elements of this would include, for example, the data center domain. That's an interesting approach, and perhaps it means we need to be a little more explicit about the criticality of data centers as part of even the project plan. So thank you for that. And in fact, let me say the following. When the plan is sent around, I would very much appreciate any feedback on how to improve it. So anyone who wants to see the plan, just get in touch with someone on the council. We'll get you the latest version.
It's on the site. It's already there.
Get back to us on what changes you'd like to see. Craig.
Over lunch, a few of us were talking about a working group that couldn't be formed here, given the participants here, but kind of a corporate working group, and this ties into, I believe, Susan's idea here with this, every company is involved with cloud computing, and they've got financial security issues. And these are stakeholders that should absolutely be aware of this problem and really funding kind of conferences like this to sort of encourage these working across industry sectors and independencies. So I just thought that, I was talking to Tom Popick about this and a few others about the corporate, the self-interest, if it wasn't for the good of humanity, then just with their own business continuity. So perhaps as a part of the working group constellation, we might consider like a corporate group, and it might form around some of this financial resilience and these data centers, because it's all, we need the corporates in here. I know you say that it's going to be a while and they're going to be involved in it, but let's get them involved as soon as possible.
Yeah, look, I think it's absolutely critical that corporations be involved and find a way to work together. I think this umbrella, the Human Continuity Project umbrella, represents one approach to do that. It could be that forming a sort of an interim working group to lead toward that might be a method. Let's think about that a bit more and follow up on it. But before I let you completely off the stage, so to speak, let me just introduce you to the group. This is Craig Snyder, and Craig and his foundation have been absolutely instrumental in enabling conferences like this and all the work we're doing. So I'd like to have a big shout out for the work, Craig, that you are making possible. Thank you, Craig. Okay, anything else, or should we all go home? Sounds kind of good to me. I think it. Okay, we have some administrative effort. It'll only be another hour and a half, so relax.
In my time, I'm done. I'm going skiing. So a big applause to you guys. I mean, this has been terrific, no? What do you think? Yeah? Yay! So I earned my vacation, I think. Okay, so a few things that, Sam, can I get my slide? Maybe. Okay, good. So membership. Everything we do, we have a huge community of members. We would love you to participate in that. So just visit our website. Our website has all the projects we discussed today. For example, what Scott described earlier today, we have a full page with all the information that he mentioned, and also you can see all the process and the plan. Same for the Human Continuity Project. You can download the plan there. You have a really nice brochure that is digestible. And follow us. I mean, social media is not that amazing in my opinion, but we do post all the information there about our upcoming events, and we have a lot of those. And we have great people as you participating in our conversations about everything that is happening in the resilience world. Mani, where are you going? We will miss you. We'll see you in London. And that takes me to the next point, London. We are going to meet in London. And there are Richard that visited us last time, right? Too much pretzels for me. And we are looking for partners. And we are looking for speakers. So if you think that you would like to participate, or anyone from your organization, please let us know. Okay? Okay? Good. Thank you. It's been a pleasure. I'm stuck with it. Thank you.
Hey, thank you, Leahy. Thank you, Chris. And thanks to the entire team, PJM and EIS Council, for putting this on.
Yeah, thanks, everybody. Thanks for your energy. Thanks for your engagement. Good to see you all in person. It's been a while for a few of us, so Thank you. Safe travels. We'll be in touch very soon.